This comprehensive video tutorial introduces you to Supabase by building a real-world React.js Sales Dashboard app with authentication, real-time data operations, and secure user management. Supabase is an open-source backend-as-a-service platform. You will learn about database and schema design, authentication and session management, security and access control, and more. Jonathan Hill from Scrimba developed this course.
Welcome to the Intro to Supabase course here on Scrimba. My name's Jonathan Hill, and I'm super excited that you are here. Now, I pledge that is the first and last super joke you will hear from me. Right off the bat, I want to let you know that during this course, you will have to sign up for a Supabase account, but everything we are using falls within their free tier, so no need to dig out those credit cards. So what is Supabase? It's an open source Firebase alternative founded in 2019. Both Supabase and Firebase are backend as a service, or BaaS, platforms. This is when we outsource the behind-the-scenes aspects of a web or mobile application so that we only have to write and maintain the front end. Supabase is a database infrastructure based on Postgres with a super simple setup and interface. So why do we need it? Well, you know when you're building a full-stack app, you have a front end and a back end. And on the back end, you need somewhere to store your data, to authenticate, store assets. Perhaps you want some AI features with vector embeddings. Well, this is where Supabase takes over. It aims to get developers started and set up quickly. That's exactly what we're going to be doing in the next Scrim. However, it still allows for more complex engineering features and scalability along the way. Supabase provides backend services along with front-end client-side SDKs that can connect this infrastructure to your JavaScript frameworks. More on this later. When you see it in action, trust me, it will make more sense. Now, I'm not going to lie, the choice between Nicki Minaj or Dan Aykroyd was tough. Anyway, onwards. So being the dependable developers we are, a new user story has just dropped and we are keen to get started. This is our task for the course. The sales team are requesting a new sales dashboard. They are looking for a chart for the total sales for the current quarter for each rep. They'd like this chart to update in real time. So whenever a deal is added to the database, they'd like it to immediately update. The format for the data in the database, they'd like it just name and amount, as this is what they've been using so far, and they want the option to be able to import the data in this format. And they'd like a simple form to add a deal to the database. So, what are we going to be studying? Well, we obviously need to create a Supabase project and table, and you're actually going to be doing this yourself. So when you're watching me during this course, I will be interacting and using data from my own Supabase table. But during challenges, the Scrimba platform will seamlessly let you work with your own Supabase table. This is done with environment variables, which I'll talk you through setting up shortly. We're going to connect the database to the front-end code, which, lucky for you, has already been provided, so you won't be having to code it yourself. We're then going to be querying the database to fetch all the data in the table. We're then setting up this real-time subscription. And lastly, working on inserting data into the table via the form. And of course, because we're here on Scrimba, lots of challenges to get your fingers on the keyboard. So what should you be familiar with? And note, I'm not saying an expert in, just familiar. Some SQL basics, some essential JavaScript concepts, some React basics, as we're going to be using React for our app, and hopefully you've worked with APIs before. Now, if you've not worked with React, I really recommend you click on this slide to take you to Bob's fantastic Learn React course here at Scrimba. It will mean that a lot of what we're doing here makes much more sense. And it's also available for free. A quick word on who I am. I've been dabbling with code for a few years, and I'm a graduate of the School of Code Bootcamp. If any of the alum are watching, I hope you've done your squats this morning. I'm a former music teacher and musician, worked for a few years on cruise ships, and I'm a very proud cat dad to 2 Siberian fluffs. On the Scrimba Discord, I'm down as Jonathan Hill, so please do search for me, send me a message, send me any questions. I'm more than happy to help. Speaking of Discord, at Scrimba, we give every one of our students access to a Discord community where you can celebrate your wins, ask questions, get help, get code reviews, and even join a weekly town hall meeting. This Discord is available to free and pro members. Also, if this is your first time watching a course on Scrimba, many of the images in these slides are clickable and will lead you to somewhere. So, for example, if you click on this screenshot of our Discord server, it will send you to an invite for joining. I'll try to remind you when something is clickable on one of these slides. All right, let's get going. Welcome to Section 1. My name's Jonathan Hill, and I'm excited to take you through this section on persistence along with Section 2 on authentication. We're going to be using React along with supabase. Right off the bat, I want to let you know that during this course, you will have to sign up for a supabase account, but everything we are using falls into their free tier, so no need to dig out those credit cards. So, what is supabase? It's an open source Firebase alternative founded in 2019. Both Supabase and Firebase are backend as a service or BaaS platforms. This is when we outsource the behind the scenes aspects of a web or mobile application so that we only have to write and maintain the front end. Supabase is a database infrastructure built on Postgres with a super simple setup and interface. We're going to see that in the next few scrims. So why do we need something like Supabase? Well, you know when you build a full stack app, you have a front end and a back end. And on the back end, you need somewhere to store your data, to authenticate, store assets. Perhaps you want some AI features with vector embeddings. Well, Supabase comes into play. It aims to get developers started and set up incredibly quickly. However, it still allows for more complex engineering features and scalability along the way. Supabase basically provides back-end services along with front-end client-side SDKs that can connect this infrastructure to your JavaScript frameworks. More on this later. When you see it in action, trust me, it will make sense. Now, I won't lie, the choice between Nicki Minaj or Dan Aykroyd was tough. Anyway, onwards. So for these two sections, we're going to be working through some user stories. So you're suddenly in a dev team at a sales company, and this user story has just dropped. We're being asked to create a bar chart showing total sales for the current quarter for each sales rep. They want the chart to update in real time when new deals are added. The current deals they have are in a particular format, name and amount, so we have to stick to that going forward. And then they're also interested in a form to be able to add new deals to the database. So what are we going to be learning in section 1? Well, we're going to be creating a Supabase project and table. We're going to be connecting this database to the front end. Most of the front end code for these sections will be written for you. We're going to query the database to fetch the data. We're going to be setting up a real-time database subscription, and we need to insert data via the form. And of course, because it's Scrimba, many challenges along the way. When you watch me during this course, I will be interacting and using data from my own Supabase table, but during challenges, the Scrimba platform will seamlessly let you work with your own database. This is done via environment variables, which I'll talk you through setting up shortly. As I said, I'm Jonathan Hill. I'm a School of Code Bootcamp grad. I've been dabbling with code for a few years now. I'm a former music teacher and musician. I spent a few years as a guitarist on cruise ships, and I'm a very proud cat dad to 2 Siberian fluffs. In case you're not aware already, at Scrimba, we give every one of our students access to a Discord community where you can celebrate your wins, ask questions, get help, get code reviews, join a weekly town hall meet, and loads more. This Discord is available to free and pro members. Do click on this slide and it will take you to an invite for joining the Discord community. Okay, that's enough chat from me. Let's get going. See you in the next scrim. Okay, let's get going. So the first thing we're going to do is install React with Vite. Then we're going to create a Supabase project and sales deals table, and then connect to the database via the client library. As I mentioned in the first scrim, thanks to Scrimba, during your upcoming challenges, you are able to work with your own table and data. When you watch me, you'll be seeing data from my project. This is why we spend this scrim getting you, the student, all set up. You'll see how we're going to do this in a second. So we're going to create a React app using Vite. I'll run npm create Vite at latest dot dash dash, and then we're going to use the React template. So if you're interested to learn more about Vite, do check out Shant's Intro to Vite course here on Scrimba. Yes, to proceed, then we're going to npm install, and then npm run dev. And we then see in the mini browser the Vite and React boilerplate code. So let's create a new Supabase project. Please click this slide to take you to supabase.com and then click the green Start Your Project. If you already have a Supabase account, sign in. But if you don't, click on Sign Up Now at the bottom and you will have to confirm your details in an email. If you sign up, the first thing they will ask you to do is create an organization. This can be anything. I'm going to go for Jonathan's team. Then click Create Organization. If you already had an account, you'll need to go to your All Projects dashboard, which looks like this, and then click New Project in green. That should take us all to this Create a New Project page. We've got my organization name there, and I'm calling this project Sales Dashboard. You could call it whatever you want. Make a note of the database password that you generate or come up with. Pick a region close to you, and then click Create a New Project in green. Awesome. We've created a new Supabase project with its own Postgres database. Time to create a table. At the top left, you see the house. That's the project homepage. If you go down one, that's the table editor. So click on that, and it should look like this. We start off in the public schema, which is where we want to be. And in the middle, we're going to click the green Create a New Table. I'm calling my table sales_deals. Please call yours the same because we're going to be referring to this table in our code later on when we make our Supabase requests. It'll make it a lot easier if your table is called the same as mine. I'd like you to untick Enable Row Level Security. RLS allows you to define policies which control access to individual rows in the table. We're going to be talking about this in a later course, but for the purposes of this project, let's untick it and then confirm to turn it off. Click Enable Realtime here. This will mean we don't have to dive into the Supabase settings later on when we set up the Realtime subscription. This means that any changes in our table are immediately reflected in our bar chart. Then scroll down and we see that Supabase automatically generates an ID column and a created at column. We are going to create two new columns, so click Add Column. We need a name column, which is type text, and then click Add Column again and create a value column with type int4. And then once you've done that, save bottom right. And here is our table. So the name is on the left and it's empty right now, but we see the four columns we have. ID, created at, name, and value. Supabase lets you import data from CSV, but we're going to import a few rows manually. So click the green Insert and then Insert Row. I've inserted a row with name Jim and value 3000. This is because I'm going to go for a The Office US theme, as long as you all agree not to tell Gervais. All right, good. You can pick any name you want to personalize your project. I do recommend using values in the thousands for now, okay? So your first challenge now. The video is going to pause and I'd like you to work through this. Please insert more rows until you have at least 3 different sales rep names in your table. Remember, these names can be anything you want. Make sure the highest value that you choose is not tied with anyone else. So pick a highest value, say 7,000, and make sure only one row has that highest value. Make sure it's not tied. And please make sure at least one sales rep is duplicated. So if you did have a row with Jim, you could create a new row with Jim so that there are 2 with Jim. And a quick warning, make sure there's no white space either side of the name. All right, good luck. See you in a minute. I hope that went well. Here's what I went for. I've got Jim, Andy, Dwight, Andy, and Dwight. So I've got 2 Dwights and 2 Andys. And I chose 6,000 as my highest value, and I just have 1 row with that value. The keen-eyed amongst you might realize that I don't have a row with ID 4. That's because I made a typo and had to delete it. But to attempt to make all mistakes into learning opportunities, this demonstrates that the ID is self-incrementing. And even though I had deleted the row with ID 4, the next I inserted automatically continued with 5. Time to add Supabase to our React project. We're going to install the Supabase client library. So to do that, I run npm install @supabase/ and it's called supabase-js. So now I recommend everybody clicks on this slide to take them to the really clear Supabase docs. It has a quick skim of all of the objects and methods available in this client library. So what is this client library? Well, it's a powerful SDK that simplifies database interactions by abstracting complex API calls and providing a seamless interface for Postgres database operations. An SDK is a software development kit, a platform-specific building tool for developers. This client provides 3 things: simplicity, security, and performance. It converts your request into an HTTP request. API gateway routes this to different services. Post-REST converts the request to SQL, and the data is transformed to JSON, and the client library processes it into a JavaScript object that we will see getting back later in the course. For security, we've got DDoS protection. Prepared statements prevent SQL injection. The RLS checks happen at the database level. For performance, we have connection pooling, prepared statement caching by post-REST. If you want to learn more about what happens under the hood, I really recommend clicking on this video. Supabase released this recently, and it has some really interesting visualizations of what's happening under the hood. So time to set up this client in a separate file. So in source, we're going to create a file called supabase-client. So we're going to initialize a new client using the create client method. So we're going to import that to start with. And it's from supabase-js. And we call this create client. And we pass in the URL and key from your project. So I'm going to create some variables here. And we're going to pass these here. And then let's assign this to a variable just called Supabase so we can refer to it later in our project. Let's export that so we can use it in our components. Then here's where the environment variables are going to happen. I'll explain this in a minute. You're going to set it up in your own Scrimba. If you've used environment variables before, you might be used to using process.env. But when using Vite, variables are not accessible using process.env. This is because Vite doesn't run on Node.js during the build, so we have to use import.meta.env. And the Vite docs tell us that to prevent accidentally leaking environment variables to the client, only variables prefixed with Vite in capitals like this exposed to our Vite process code. So let's go for supabase_URL and supabase_key. So now this Supabase variable holds the client instance returned by the create client function. Okay, that concludes us establishing a connection to the Supabase client. To find your unique project URL and key, I'd like you to navigate to your project dashboard. That's the home icon in the top left. It should look like this. And then scroll down to Project API. Here is your project URL and API key. Now there is a bug in Supabase. You may see JWT secret is being updated and a spinning wheel. If you do, don't fret. All you need to do is on the left here, you see View API Settings. Click that button and it will take you to a slightly different page, which you'll see the project URL at the top and the API key underneath, and it's the anon public key you're looking for. So you are going to be copying these into Scrimba in a moment. If it's your first time using environment variables on Scrimba, I really recommend clicking the screenshot in the middle here, and it will take you to a brief tutorial. There's also a scrim you can watch to show you how to set it up. When you name your environment variables, just like you can see in this screenshot, I really need you to make sure that they are all capitals, vite_supabase_URL, and vite_supabase_key. They have to be exactly the same, otherwise it won't quite work. One option, you can try Command or Control Y to lower the presentation and then copy this from that supabase-client file that should be behind the slide. There is a section in this tutorial which mentions using the import.meta.env rather than the process.env when using Vite. So pause the video and get these environment variables set up. Excellent, we are now connected to our Supabase project. Next, let's learn how to query the database. We've done all the setup. We have a Supabase project and table. We've seeded that table with our data. We have imported the Supabase client library and we've set it up in a new file ready to be used. We're ready to start seeing a response back from Supabase. So first, let me show you the boilerplate code that we're starting with. We have a header at the top and then a dashboard component below. So the header is just the icon and then this H1, and the dashboard is just an H2 right now. But this is where we're going to be coding in this scrim, and this is also where the bar chart eventually will live. Supabase provides us with a translator where we can type SQL into the browser and it will translate it into the Supabase client code that we can use in our app. So please click the slide. It will take you to the translator as you'll be using it very shortly. Now, before we start talking about querying the database for our bar chart, we're going to start one step before that. I'm going to talk through how we query and we find the largest deal in our table. So the reason I asked you to make sure one row of the table had a rep that had a deal larger than everybody else, that's the one we're going to be querying now. So I think about the SQL I need for this, and I've gone for select name and value from sales deals. Because I want the highest deal at the top, I'm going to order by value and then use the desk and then only limit by one so that I only get the one highest deal. I scroll down and I click JavaScript and it gives me the client code here. It's a similar syntax to SQL. We've got a .from for the table name. We've got a .select. Here it's got name and value. And then we've got a .order and it gives us ordering by value, and then it's got an ascending false and then .limit. Now the .select part here, and later we're going to be using .insert, are actual methods available in the client library. If you want to know more about that, do check out the Supabase docs. Now I copy and paste this into the dashboard component. Now the backticks here are purely formatting so that we can have the name and value on separate lines. It would work equally well if we just had it on one line with regular inverted commas like this. Now this Supabase word here is actually the client instance that we exported here in the separate file in the last scrim. So we need to import that at the top here, and we're going to use the dot because this dashboard component is on the same level as the supabase-client.js file. And then we see the await word, which implies this function needs to be asynchronous. Now, why is this? Well, we need to pause the execution of the function that we're going to wrap this in a minute until data is fetched and available. We don't want to use it before the Supabase query resolves. And then since we want this query to only happen on first render, we need to think about a way to do that. And the industry standard way in React is to use the useEffect hook. If you need to brush up on the useEffect hook, please click this slide and have a read of the React docs. Or better still, click this slide to check out the useEffect lesson in Bob's fantastic free Learn React course here at Scrimba. So it's a challenge time for you to get your hands on the keyboard. I'd like you to import the Supabase client at the top. I've removed it. You're welcome. And then number 2, we're going to wrap this client code in a function. I'd like it to be called fetch metrics, and it needs to be asynchronous. Then I'd like you to import useEffect at the top and add the use effect hook up here at the top of the dashboard component. And I'd like you to call the fetch metrics function that you've just written as the effect in the hook and have it run only once after initial render. You may need a Google for that. Then I'd like you to log the response from Supabase to the console. Now, right now, the response is being destructured into these variables. What I recommend is you comment out this and create a new variable called response. And then below this, I'm giving you a lot of help now, you can just console log the response variable here. Okay, that's the way I would do it. But let me remove this so you can have a go yourself. And then in the past, if you've used Scrimba before, you may be used to just refreshing the mini browser to run the code. But now in the new Scrimba, it's going to be a Control or Command S to save, and that will run it again. And you can bring up the console and check if we're getting a response from Supabase. Good luck. Okay, I hope that went well. Let's go through it step by step. So we're going to import Supabase here. There we have it. And then we're going to make an asynchronous function here. So we say async, and we're going to call it fetch metrics. Then we're going to wrap all of this in here. Now we need to import use effect at the top. There we go. And add the hook at the top. So we just call use effect. And then in here we need an arrow function. And this is where the effect is. And then here we need a dependencies array. So if the dependencies array is empty, then this will only run after first render and not on every re-render. So I've asked you to call the fetch metrics function as the effect here. So let's do that. And then number 5, log the response to the console and save. So I recommended that we commented out the destructuring. We then assign this to a response variable. And then below we just console.log that response variable. So we can see everything coming back from Supabase. I'm going to go for Command S. And then I check my console and hey presto. This is everything we're getting back in the response. We've got an error property. We've got a data property. Those are the two that we're interested in, and that's why Supabase suggests we destructure these into data and error variables. Do check the React docs if you need to brush up on the destructuring assignment. Fantastic. So in the next scrim, we're going to be querying the database for the data we need for our bar chart, which is the end goal in this project. See you then. In the last scrim, I showed you how to query the largest deal in our Supabase table, but now it's your turn. Our final goal is to make a total sales this quarter bar chart. So that's the query you are going to write now. So have a think of the SQL we need because you're going to be using that Supabase translator that you saw me use in the last scrim. We're going to need the name and then a combined total of that rep's deals. So basically a total sum of the value column when it's grouped by each sales rep. And we want it to return a single value, the total. We're going to have to run some code in Supabase to enable, hint, hint, aggregate functions. Because of the potential performance risks with these, they've actually been disabled by default by Supabase. So we can enable them by running some code in the Supabase SQL editor. So if you head to your dashboard and on the far left, just below the house is the SQL editor, click that and that will take us to this screen. And in a second, you're going to be given the code in the challenge to paste up here and then click on run bottom right, and that will enable these aggregate functions. So challenge time. So here is the code you need to run in that SQL editor. And then I'd like you to write the SQL for this total sales this quarter bar chart in the Supabase translator. So there's a bit of a hint here. And you may see an error at the bottom of the translator, which may prompt you to get involved with the group by. And then you click JavaScript and then copy the client code that it gives you into the fetch metrics function here. And then you can log the response to the console. So you remember in the last scrim, I commented out the destructuring that Supabase gives us, and then I created a const response, and then the whole response from Supabase I assigned to that variable, and then below it I just used a console.log response. And then save and check your console. Good luck. Okay, I hope that went well. Let's go through this. So I have run this code in my Supabase project, and now I'm going to write the SQL for number 2. So I'm thinking about what I need here, and I definitely need to select name, and then I need to use this aggregate function. So if I'm adding up, I think I need the sum. So this is what I've gone for here. Select name and sum the value from the table. But here's that error I mentioned. Supabase reminds us that every non-aggregate select target must also exist in a group by. So name is a non-aggregate select target. So what we need to do is add group by name, and the error goes away. And then I click JavaScript, and then the code it gives me, I'm going to paste here. So it's given us a from the same table as before, but the select is slightly different here. We've got name, and then it's value.sum in the Supabase syntax. Now, as before, to log this to the console, I'm going to comment out this and then create a const response. And then below, I can just console log the response variable. And I save and I cross my fingers. And yes, here we are. This is the whole response we're getting back from Supabase. And the parts we're interested in is the error key and the data key. So that's why Supabase suggests we destructure these into variables. So in the data key, we've got an array of objects. And this is Andy's deals summed up. And this is Dwight's deals summed up. And Jim's deals. This is for my project. But you should have seen the summed up values for your project. And then if there was an error, it would be here. Now, on to storing this data somewhere so we can use it in our app. See you next time. Time to store the data we've received from Supabase in state and handle any potential errors we get back. Okay, challenge time again. I'd like you to import useState up at the top here and create a new state variable. That's going to be right at the top of the dashboard component. Please call it metrics and include a corresponding setter function and then initialize it as an empty array. Then use the try-catch syntax in the fetch metrics function. I'd like you to wrap all of this in the try. That's the Supabase request. And then if there's an error, throw this error. After this if statement, log the data variable, that's this one here, to the console and use the state setter function that you made in challenge number 1 to store the data variable in the metric state. Then catch the error, that's this error variable here, and log it to the console with a custom message. Save, Command or Control S to check that everything's working as it should. All right, good luck. Okay, I hope that went well. So let's work through this challenge. I'm going to import useState here because it's also from React. And then I'm going to create a new state variable. So let's call useState. And let's pass in that empty array that we're going to initialize it with. And then we're going to make the state variable and the setter function. So in square brackets, we're going to call the variable metrics and then set metrics for the setter function. Okay, number 1 done. Number 2, try catch syntax. So let's set that up here. There's the try, and then we're going to catch something and do something with that. Okay, that's all ready for later. So we've wrapped the Supabase request in the try. Now number 3, if there's an error. So we need an if statement. So if any error, we're going to throw that error. After this if statement, log the data variable to the console. Console.log data. And use the state setter function to store this. So we called our state setter function set metrics. And we're going to pass in the data variable. Number 5, catch the error. So we're going to put error in here because we've thrown it here. And log it to the console. So now we can use console.error. And let's say error fetching metrics, because that's what we were doing. And then the actual error. Brilliant. Let's command and save and check the console. And yes, we're still seeing the data logged here. So that's still working. But importantly, we are now updating state with the data we're getting back from Supabase. In the next scrim, we're going to be formatting this data ready for our bar chart. See you then. Now that we have the data stored in state, we could do any manner of things with it. Make a leaderboard to inspire the sales reps to jump on the phones, or create a nifty bar chart that could be part of a larger dashboard of visualizations. That sounds like a good idea. This scrim will be more data manipulation and creating the bar chart than pure Supabase, so feel free to skip if you want, but if you're going to stick around, let's get cracking. After updating state with the Supabase data in the last scrim, we are now holding an array of salespeople objects. These objects represent each metric, or bar in our case, we want in our chart. So name is going to be on the x-axis and the sum is going to be on the y-axis. We are going to use the React charts library to create our bar chart. The legal team have advised me I must make it clear that other libraries are available. Ooh, that was close. So to install React charts, we need to run npm install react-charts at beta-save. And then we're going to import it at the top of our dashboard component because this is where the chart will live. And it's only the chart that we're going to be using. And it's from React-charts. Brilliant. Now, I'm not going to go through every single part of this chart, but here's the chart we just imported. And then we've got an options object with all of these options in it. We've got a primary axis. So I need to quickly write that at the top. There we go. And then we've got secondary axis. Don't worry too much about these. This is just going to make sure our chart looks really great. And then I've written a little function that is going to make sure the bars of our chart don't touch the top of the chart. That's taking in the metric state variable there. You can have a look at that in your own time if you want to. But the important part here is this data property, which is a chart data variable. So let's create that above here. And this is where we're going to manipulate the data we have in state into the correct format. The React chart docs tell us that the data the chart component needs must be, and now I hope you're ready for this, an array of one object which has a single data property. Value of this property must be an array with each metric you want to plot as an object with primary and secondary properties. These will relate to the primary x and secondary y axes. Since we want the name plotted on the x-axis and the summed up deal value on the y, it needs to look like this. So that's what we're going to do. Since you've had quite a few challenges recently, I'm going to take the reins for this one. I can hear you thinking, Jonathan, you are too good to us. Well, you are correct. You might have realized, but since we have a metrics array, that's the state on the left, with objects in this format, but we want a data array with objects in this format on the right, I'm going to use the array map method. Each item in the data array will be an object, the metrics state's name value mapped to the primary property, and the sum mapped to the secondary property. So let's set up our chart data array. So we start with an array, and that's got one object which has the data property, and the value of that is going to be an array. Okay, so that's set up now. Now remember, the data array is going to be made up of objects. So we're going to map around the metrics state variable, and then we need a callback function for each array element. So we need to call the old element something. Let's go for M for metric, and then we need the arrow and the smooth. So anything in the smooth is going to be the element in the new array. And we remember the new array is going to be made up of objects. So we create an object, and that object is going to have a primary property and a secondary property. Okay, and the value of the primary property is the old element's name value. So we access that with the dot syntax. .m, remember, is the old element, and we're accessing the .name. Let's just have another look. So .name there is going to primary, and then it'll be m.sum. Have another look. Can't be too careful. Name goes to primary, and sum gets mapped to secondary. Okay, very nice. Let's save. And hey presto, the mini browser shows us our bar chart. We've got name plotted on the x-axis and the aggregated sum on the y. We did it. We are fetching aggregated data from our table and displaying it in a bar chart. Next up, we will be setting up the real-time update so any changes in our table are immediately reflected in our chart. Whenever there are any modifications to our database table, for instance, something's inserted, changed, or deleted, we want those to be immediately reflected in our bar chart. We can imagine that a different sales rep adds a deal. We want to see our chart change immediately. That's where Supabase's real-time subscription comes into play. Supabase refers to these updates as events, and we want to subscribe to these changes. Just like in the olden days, when you subscribed to a magazine, as soon as a new edition came out, it would be sent to your address. Or these days, if you subscribe to a podcast, as soon as a new episode comes out, it is sent to your podcast provider. This provides a seamless way to keep your application synchronized with your database. One of the 3 core extensions of Supabase Realtime is Postgres changes. And funnily enough, that's the one we're going to be using in this course. It listens for database changes and sends them to the client. So the different events we can listen out for are insert, update, delete, or star, which they use for all 3 of those. We can receive event information, so exactly what's changed, and we can trigger actions at this time. Since we want to start the subscription only once on initial render, let's think about where we need to write this setup code. What else is already happening only after initial render? Well, I don't think we want it in the main body of this component, but we do have this use effect. Now, if we remember when we set up the fetch metrics, we only wanted that to happen on initial render. So I think that's going to be a good place for us to write this code. Remember, with the empty dependencies array, this means that this will only happen once after initial render and not on every render. If it did happen on every render, then we'd be setting up duplicate subscriptions, which would be bad. Now we want to make sure that we fetch all of the data before we set up our subscription, so we're going to want to code after this fetch metrics function call. Setting up a subscription is an operation that reaches outside the React rendering cycle to interact with an external system, i.e. Supabase. So it's a side effect that should happen after the component renders. And use effect is designed to handle side effects, so this is the perfect place. Okay, challenge time. I've copied the challenge text here and some boilerplate code here that you're going to complete. So here is the Supabase client instance, and then we're using .channel. This is where we can choose a channel name, and I've asked you to call it deal-changes. Then we've got a dot on, and here's that Postgres changes I mentioned earlier. Then we have an object with event, schema, and table. So you need to think about what to put in event, since we're going to listen for all types of events. Then the schema here, and the table name here. Then they give us a payload object, so here is where we'd write any action we want. And I've asked you to log the new property of this payload object to the console. We're going to talk later about what this cleanup subscription here is. Before I set you off on this challenge, one more thing. When we created this table, we actually enabled real-time, if you remember. It said broadcast changes on this table to authorized subscribers. We have it all set up, but in case you missed that, or if you just want to know how to do it in the settings anyway, you would need to select the database icon on the far left, which is the 4th one down, and then click Publications. We can see Supabase Realtime here in the middle, and you've got the different events, insert, update, delete. And if you click the source, the one table there, that's because I have enabled it on our sales_deals table. Okay, so once you've saved it, then navigate to your Supabase table editor and insert a row and check the console. Good luck! I hope that went well. So we are going to call the new channel deal changes. We are going to listen out for all events, so that's the star. schema is the public schema. You will have seen that in your table editor. And we know the table is sales underscore deals. Now to log the new property, we're going to do console.log payload.new. Then I'm going to save. And I check the console, and here is that payload.new. So that's actually another object, and we've got our 4 columns here. So I went for Dwight and a deal with 2000 value. We could destructure this if we wanted to use this. We could call the new property new record, and then there's also an event type property of the payload which might be useful. And then we could even destructure it again and create name and value variable from that new record. So it's quite common to see things like this. We can do an if event type is equal to insert and then do something with that, especially if you wanted to do something different depending on the event. A quick note on the old record, if you were listening out for an update or a delete, by default, it's only the new record changes that are sent. But if you did want the old one, you can run some code in Supabase to enable that. So if you're interested in that, do have a Google of. But we're actually not going to do any of this. We are just going to refetch all of the data with our fetch metrics function. Now, if you had a really large data set, this would not be very performant because any tiny change in your database, you'd have to refetch everything. But since we're using such a small data set, I think it's okay for our project. Now, a quick word on this cleanup function here. So this cleanup code runs when the component unmounts. Real-time subscriptions establish persistent connections that need to be properly set up when a component mounts and cleaned up when it unmounts. The return function in this useEffect hook runs when the component unmounts, which is the perfect place to unsubscribe and prevent memory leaks. And once again, the empty dependencies array means this cleanup only happens when the component unmounts, not on re-renders. And here we've got the Supabase client instance, and then a .remove channel, and then we pass in the channel that we created here. All right, see you in the next scrim. We're on to the part of our user story to create a form to add a new deal to the table. The fabulous front-end team have built us a form to be able to choose a salesperson and amount to add a new deal to the database. Here it is down here. We've got a name drop-down, we've got an amount, and we've got an add deal button. Let's have a quick look through this code. So I created a form.jsx component, and here is the form. We've got a container, we've got the form, we've got label and a select, we've got a label and input, and we've got our button here. Now you can see here we've got a metrics prop. So if we scroll down in dashboard, we see that at the bottom, we're passing the metrics as a prop to the form component. And then I've written a quick generate options function here. This is mapping through the name keys in metrics to create options in the select. Here is generate options. So that means all of the names in our sales deals table will be available to choose in the drop-down. This is okay for now, but in the real world, you'd want to be getting all of the names of your salespeople from a separate table in the database. Currently, if any salespeople don't have deals, then they won't be available to pick in the drop-down. Now, for all of the forms in this course, I'm keen to use the new React hook useActionState, which was introduced in React 19, along with React's form actions. I'll start by explaining the form action prop. I've just written an example.jsx here, and this is just what we're used to when it comes to forms. In my little example form, all I have is an input and a button. And here is the action prop. We're used to having separate state for loading and an error message. But instead of an onSubmit, we provide this action prop to the form. Since action is not an event handler, the function we pass to it doesn't receive the event as a parameter, as we would have done in the past. But instead, we receive info from the form in this form data. This is a native web form data object, so we have access to all of the information from the form without having to track it in local React state. So we don't need to prevent default, we don't need to clear input after submission, and we don't need the value property on an uncontrolled input. Then we use this .get on the form data object, and this allows us to get info based on the name attribute. So I think the best way to explain the use action state is to modify this little example step by step. So use action state tracks the component state, the pending status, and provides a wrapped action function for use in our form. So let's start by removing the loading and error state. You'll see why in a second. And then at the top, we're going to import use action state. And then at the top, we're going to call it here. Now we destructure the array that we're getting back, and we get 3 values back. The first one is the state we want to maintain inside our component. Let's call that state for now. The second one is an action function. Let's call it action function for now. And the third is a Boolean, which is automatically updated depending on the current status of our form. In the docs, this is often called isPending. You can call it anything you want. You could call it loading, but let's keep it isPending for now. Now I need to update the action prop here to be this new action function. And we actually define what the action function does here in a second. Now we pass 2 arguments to this use action state. The first one is the handler function, the action we want to run when the form is submitted, whenever action function is run. Let's just call that function for now. And the next one is the initial state. So let's have that as an empty string. So this would be the initial state of this first value here. You could put null if you don't really care what it starts at. So because use action state actually controls the state of the component, let's change this to name and we can get rid of this use state. So because we already had this form action function here, this is what we need to put into this handler function here. And let's turn it into an anonymous function since it's only going to be used once, and we'll pass it directly. We don't have these anymore. Now the handler function that we pass doesn't just take form data as a parameter. It also receives the previous state for our component as the first parameter. It lets you reference or build on the previous result. So for instance, if you wanted to use it for login attempts or success data, things like that. So let's add that here and just call it prev state. Then it's the job of this action function to return the new version of state, which will update name state here. So instead of set name to new name, we need it to return the new name. Remember, we've got rid of name state using use state. So let's change this to return new name. There we go. Therefore, React will take the return value and automatically update the name state value and re-render. So we're not using prev state here, but that would be for if we wanted to use the previous state in this function body. And of course, this name state value would be an object if you wanted to track multiple values. So just to round up, we call the use action state hook at the top level of your component to access the return value of an action from the last time a form was submitted. We initialize it here, and then we update it with the return value. We can use it here. Okay, so with that in mind, let's now use it in our form component. In section 2 of the course, you are going to be setting up a use action state, so do watch carefully. Start by importing use action state. Then at the top level, we call it, and we destructure those 3 values. We're going to call the state part of it error, the action function submit action, then is pending again. So let's just set up this structure. We've got our anonymous arrow, and then below here, second parameter, the initial state value, and it can be null. So let's call this previous state, and we've got form data as the data passed to the action. So we've got action logic, then the async operation, and then we need to return the error state. And just to remind us, let's put initial state here. So our form doesn't actually have the action prop yet, so let's add it in. And we're calling it that second there, submit action. Okay, so let's extract the name and the value from the form. Let's define an object called new deal. We need a name property and a value property. And we use the .getOnFormData. And then it's whatever we've called the name select, funnily enough, name. And the value, can probably guess, but we do want to check. Excellent. Okay, brilliant. Let's log this new deal to the console. And I just forgot, we obviously need to also return the success, and that would just be null because we don't want to update error because there's no error because we have been successful. Okay, so let's do a little bit of accessibility here. Now that we've got this error state, we can use it with this aria invalid. And we can say if there is an error, then we want aria invalid to be true, and if not, false. And then for disabled, we can use our is pending. Same thing for the value. Good stuff. And for the button. And we've got a reminder here that why don't we let the button say adding deal if is pending is true. Actually, let's just go for adding. There we go. We should put an error message here because we've got that error state. Let's say if there is an error, let's render a div with the error message. Okay, that looks good now. So now if we add a deal with our form, we should see the new deal object with a name and value property logged to the console. And add a deal for Andy. Let's go for 3,000. Fantastic. In the console, the new deal object is logged. And the Andy name is coming from that name dropdown. And the 3,000 is coming from the amount input. Okay, in the next Scrim, you are going to be finishing off this so that we can actually add the deal to our table in our database. See you then. Time for a challenge to insert this data into our table. Firstly, I'd like you to import the Supabase client. Then, number 2, under this async operation, I'd like you to write the client code to insert the new deal object into the table. Only destructure error and use the .insert this time, passing in our new deal object. Then, for the error state, use an if statement to check if there's an error back from Supabase. That's the error you destructured in number 2. Log any error to the console and use that error constructor to return an error object with an appropriate message. Then save with Command or Control S and use the form in the mini browser to add a new deal. You should see the new deal state being logged to the console, and thanks to the real-time subscription, the chart update. Do have a look at the Supabase docs for insert data if you need a bit of help. Remember, in Dashboard, we destructured data and error, but this time you only need to destructure error because we're not going to get the data back. All right, good luck. See you in a minute. Okay, I hope that went well. So let's import the Supabase client at the top. And then we're going to do the next part under async operation. We're going to destructure the error from the response. So let's do that to start with. And because this is async, we need a wait before the word Supabase. And then we still need to specify the table with the from. And we've been told to use the .insert this time, passing in our new deal object. There we go. Number 3, below this, we can do it here. Use an if statement. If, to check if there's an error. So if error, this is referencing this error. And then curlies. What are we going to do if there is? Log any error to the console. Let's go for console.error. And what are we doing here? We're trying to add a deal. So error, adding deal. And to give us a clear, explicit error message, let's go for error.message. And it says to use the error constructor to return an error object. because whatever we return from this action function updates the error state. So we return a new error with a capital E, and this will be what we actually see on the UI. So it needs to be user-friendly, failed to add deal. And they're not interested why, but we are in the console. Hence, we actually log the error from Supabase. Okay, let's get rid of these comments. And I save, and let's see what happens. I choose Dwight, and let's go for a deal of 3,000. And we see it in the console. And Dwight has gone up from 1,000 to 4,000 in our bar chart. Fantastic. This completes this part of our user story. See you in the next Scrim where we wrap up section 1. That's this section finished. Great work. What have we learnt? Well, we now know how to set up that Supabase project and table, use the client library to connect our front end to the database, fetch data from the table, set up that real-time subscription, insert data via the form. It is really recommended here on Scrimba that you connect with the Discord community, share your progress, read what everyone else has been building. Hopefully it will spur you on to continue into section 2, authentication. See you there. Okay, we're on to this new section on authentication. A new user story has dropped. We've now been asked to allow a user to sign up as either a rep or an admin account type. They want to be able to sign in and out. They want reps to only be able to add deals for themselves, whereas admins can add deals for any of the reps. They want there to be data security, so people who are not logged in can't see the data on the chart. And a last quick thing, they want some of the account information about who's logged in to be in the header of the dashboard. That means we're going to be setting up router and context, listening for a session, learning about JSON Web Tokens, signing users up and in, and I guess out as well, and writing some row-level security policies, and a database trigger, plus, of course, challenges. If you need motivation, check out the Scrimba Discord community, see what everyone else has been building, and then let's get going. See you in the next Scrim. To implement authentication, we need the user to be able to sign up, sign in, and also see our dashboard. We're going to utilize React Router DOM for this purpose, so that there can be different routes for the sign up, the sign in, and the dashboard. In case you've not come across React Router DOM, it allows client-side routing without full page reloads. This creates a smoother, more app-like user experience compared to traditional server-side routing. It allows us to maintain the URL that reflects the current state of our application. So the URL would say /signin when they're in the sign-in component, or /signup, or /dashboard. That means the users can bookmark specific pages, share links, and use the browser's back and forward navigation buttons. React Router DOM also makes it easy to implement authentication-based route protection, so we can prevent unauthorized users from accessing certain routes. And it enables navigation based on user actions, like form submissions or other events. So we're going to be preparing our app by implementing React Router DOM, and then next, React's Context API. But since this is mainly a Supabase course, not a React course, I'll be doing the majority for you. If you're interested to learn more about React Router DOM and the Context API, which is coming up next, click this screenshot to check out Bob's advanced React course here on Scrimba. So let's make some folders in source. We're going to need a components folder. Let's add the form and header. There we go, all fixed. And then let's make a routes folder. And we'll put dashboard in there. And we're going to install React Router DOM using npm install react-router-dom. Now we're going to create a new component called signin.jsx. So this is the flow we're looking for to start with. The user visits the home directory. They see the sign in page. There's going to be a link there which can take them to the sign up page, and a link there that's going to take them back to sign in. If there's any error there, it's going to just loop back, and similarly, any error in the sign up is going to loop back. But if there's a successful sign up, that will also sign them in. Okay. So they'll add their email and password to the database, but they'll sign in as well, and that will create a session. And also, if they're already signed up and they just sign in, that will create a session as well. And then they'll be navigated to the dashboard route. And then from the dashboard route, they can sign out, which will remove the session and navigate them back to sign in. On a successful sign in or up, because remember, they both sign in the user, Supabase sends a token to the client, and the client library creates a session in local storage. That's as much as you need to know right now. We'll be talking about this in much more detail in later scrims. So let me quickly write a boilerplate code here. And I'm going to call our company Paper Like a Boss. Okay, now let's create a router.jsx. So the element we need from React Router DOM is called create browser router. And we call it here. And this function creates a router configuration. So we call that router. And it takes an array of router configuration objects. I've changed my mind. I want you to help me out here. Time for a challenge. I'd like you, as I mentioned, to pass an array of root objects to create browser router. Each root object must have the following properties: a path and an element. So start by making an empty array and then add some objects in that array. And then each object needs to have two properties: path, the URL path as a string, and the element, the React component to render. So I only want two roots from you. The root path, that's the home path, and I want you to render the sign-in component, that new one, and the dashboard path, /dashboard, which will render both the header and the dashboard components, a bit like what we have in app.jsx. Bit of a hint there for you to help you with the dashboard path. And don't forget to import all of our components in this router.jsx, okay? Good luck. See you in a minute. Okay, I hope that went well. So let's make an empty array and then two objects. And then each object is going to have a path and an element. So why don't we copy this for our second one? And the first path is going to be home. And the second path is going to be /dashboard. And the home path is going to render the signing component. So let's import that at the top. And we need to go into the components folder and it's sign in. And the component needs to have our angled brackets and it's self-closing. And then the element for the dashboard route is both the header and the dashboard. So let's import those as well. Now, as we've got two components here, React Router's element prop needs one root element, just like a component's return statement. So if we think about a return, we have to go for smooth and then these empty fragments here. So now that's returning just one root element. So then we've got header and dashboard. Okay, brilliant. Let's clear up this. Now, let's finish off the setup of the React Router DOM. In main, we need to import the router provider and that router that we created here. So this is from React Router DOM again. And we need that router that we created. Okay, there we go. So instead of our app rendering this, we want our router. So we can actually replace the app here, and we use the router provider, and then we have a router prop, and we pass that router that we created in router.jsx. We save, and now our new home path, as we asked for here, is rendering the sign in component. There's our nice H1. And then if we manually navigate to dashboard, we see our sales dashboard. An app is now redundant. Thank you for your service. Let's delete them. Brilliant. Let's just check home one more time. Yeah, fantastic. Okay, thanks for your help with that. So we can add more routes when we need them here. Now on to setting up the context API. See you in the next scrim. Now that the React router DOM is set up, let's move on to context. Whether the user is authenticated, signed in or not, will affect which routes they can access. As I mentioned in the past scrim, when a user signs in, Supabase sends them a token, and the client library converts this data from this token into a session object, which includes info about the user. And we need to keep track of this in state through our app. Eventually, we're going to be protecting the dashboard route by saying only when there is one of these Supabase sessions can the user navigate here. We're going to be centralizing the management of this state along with the auth functions. So for instance, in sign-in, when we have a form here, we're going to be sending the info from the form, email and password, to Supabase. And that sign-in or sign up or even log out, we're going to put all of those auth functions in a file. Let me make it here. Let's call it auth context. So in here, we're going to have auth functions, things like sign in, sign up, log out, and we're going to track the session state. And to be able to access all of these in other files in our project, we're going to use the React's context API. This is a way to pass data through the component tree without having to pass props down manually at every level. It's a solution for global state management in React. It'll mean we have clean separation of authentication logic from UI components. It'll help with easier refactoring because it'll all be in this one file. We have uniform logic. All components use the same logic for authentication, reducing the risk of bugs or inconsistent behavior, and testability will improve too. So this will be user info and sign in status. Let's actually put this file in a new folder called context, and let's put this auth context in there. Okay, so the first thing we're going to do is we need to import create context from React. Then in this top level, not inside the component, we're going to create the auth context object. So let's call it auth context. And we use that create context we just imported. And now we can write our auth context provider component. Okay, I mentioned this session. Let's create some session state to hold this. This will help us see what we're doing in a minute. So let's also import use state, and then we'll make some session state here. Okay, super. So in the return here, what we're going to do is we're going to access the provider property from this object here. So we're going to use the dot provider. And the reason we have a closing tag here is because all the components inside this provider will have access to the context values. So let's make a value prop here. And we're going to create an object in here that contains the auth state and the functions. So we have more curlies to make an object in here. And the only thing we have at the moment is this session. So the way to wrap our app is we're going to provide the auth context to the children. So in main, we're going to actually wrap our app, which remember is this router, with the auth context provider here. So let's import that here. And it's from that auth context.jsx. So now this is the children of the auth context provider. So let's save main, and we go back in here and we pass the children as props. So let's extract the children. There we go. And then we can use children here to make sure that it's inside this provider. So all the components inside this provider have access to the context values. And because we've wrapped the router here, the whole app, everything we've got at the moment, is going to have access to the context values. All consumers that are descendants of a provider will re-render whenever the provider's value prop changes. So we can imagine that a session is created when a user logs in, or it's removed if they log out. That's going to fire a re-render of the children with the new session value. When React renders a component that subscribes to this context object, it will read the current context value from the closest matching provider above in the tree. So the last thing we need to do is we're going to write a little custom hook to access the auth context, the values from the provider. So let's call this use auth. And we're going to return and use something called use context. So let's import that as well. And we pass to use context that auth context object we created right at the start of this scrim. So use context is used to grab what's in the value of the provider. So now when we call use auth inside a component, that component is now subscribed to the context, which means whenever the value provided by the auth context.provider changes, the component will automatically re-render with the new value. This means the component always gets the latest authentication state and functions from the context. So let's save this and give this a crack. I want context folders to be in source. That's my little problem there. Okay, sorted. So we can now access this context anywhere we want. Let's try it in sign in. So I'm going to import the hook. And then right at the top of this component, because useAuth returns the current value of the auth context, the value, remember, is an object. Let's just see that again. It's this inner curly object here. So we need to destructure that immediately with the curlies. It's only the session in there at the moment, and that's what we're going to test now. And then we use the useAuth hook. And now session is available in this component. So why don't we log it to the console? And we save. And because we made it undefined to start with, we can see undefined. But let's test it by changing this. Why don't we go to assistant to the regional manager? So we save that and we can see immediately it's changed in the console, and that's coming from this console log here. So we're getting session here. And as I mentioned, eventually session will include lots of information about the user that we're going to be using in our app. And the fact that there is a session object will tell the app that they are authenticated and logged in. Okay, let me just clean this up. And we'll change this back to undefined. Okay, fantastic. So we now have two routes, home and dashboard. We have our auth context as a central file for our auth functions and state. We have a way to pass these through our app when they're needed thanks to context. We now need a way for the auth state session to be updated when a user logs in, up or out. That's our task in the next scrim. See you there. It's time to talk about this auth session state. In the last scrim, we created a session state variable, and we can now share this through the app thanks to the context. This is going to be a way for our app to know whether the user is signed in, authorized, or not, unauthorized. Let me briefly explain what we're going to update this to when the user is signed in. So as I mentioned earlier, when a user signs in, or up, because this will also sign them in, Supabase issues them a token, which is stored in the browser's local storage. This token is a JSON Web Token, or JWT. For now, just know there is a token, and we'll dig deeper into this later. The client library then takes the data from the token and automatically creates a session object with that data, we need to access this so that our setSessionSetter function can update the session variable and store this session object. Now here you see we initialized session as undefined. This is going to be a sort of loading checking state. And then this method from the client library we're going to use now is going to update this to either null if there's no session object in local storage, or with the data from that session object. So we have two tasks to do here. Let me just move this up. There we go. So task number 1, we need to check on first render for a session. And that's going to be using this getSession method. The reason we need to do this is because imagine if a user's logged in, then they've closed the application, and then they navigate back to the application. There's still a session, they're still logged in, and on that first render, we need the app to check whether that session exists and update our session state, which will therefore navigate them, say, into the app and past the login screen. Then number 2, if they're not logged in and they do log in, or say if they're logged in and they log out, we need some way to be constantly checking for any auth state changes, a bit like starting a CCTV or a radar. So we need to listen for changes in auth state, a bit like how we set up that real-time subscription to watch out for any changes in our database table. So both of these things are going to happen after first render. We're going to be turning on the CCTV or the radar, and we're going to be checking for a session object in local storage. So let me ask you a question. Where in React do we set up a sort of side effect after first render which reaches outside the React lifecycle? If you're thinking use effect, you are correct. So I'm going to do this bit for you, and then there's a challenge for you to do number 1 here. So we import it, and then we say use effect, and we've got our arrow function, and then here we've got our dependencies array. And because we want this to happen after first render, it's going to be an empty dependencies array. Now we're using getSession from the client library, so I'll also be nice and import that for you. Got to go back a level, and then it's in Supabase client. There we go. Let me move these up into use effect. Okay, challenge time. I know this seems like a lot, but if we have a look at this hint, we're going to follow the pattern that we used for fetch metrics here. So there is an option just to copy and paste this into auth context and modify a few bits. But if you want to challenge yourself, maybe have a look at fetch metrics and then see if you can type it out again. So inside the use effect, well, we already are here. Write an asynchronous getInitialSession function, which executes the auth.getSession method. So we've not seen this auth part, but because it's part of auth, the syntax is to use auth dot before the method from the Supabase client library. So remember here we used supabase.from and .select. We're going to need this time supabase.auth.getSession. Then destructure the response into data and error variables. It's probably good for me to show you the response we get from getSession. So if there is a token in local storage, we have an object which has a data and error properties, and the data property, the value of that is another object with a session property, which is the actual session object that we need to use to update our session state variable. And then if there's no token in local storage, that session is just null. Hence why we're going to be updating the session state to null. So I'd like to use the try-catch syntax, handling both Supabase-specific errors and unexpected errors. So just like we did here, we threw any Supabase error and caught it in the catch. So this catch is therefore catching Supabase-specific errors and unexpected errors, for instance, like a network problem. If successful, I'd like to log the value of the session property of the data object to the console. Remember, this is because it's going to be data.session to get into the data object. And then I'd like to also update the session state with that data.session. Then call the function below the function definition. And then number 6, check the browser's dev tools. Well, you may be thinking, Jonathan, why are we not just checking the Scrimba console? Well, there's a little bit of a quirk in the Scrimba environment. And when we check our Scrimba console, we actually see undefined and not null. But if you check your browser's dev tools, and for me that's using F12 because I'm using Chrome, but have a Google of how you do that if you've not done that before, and then click the console part of the dev tools, you will see it logging as null. And that's correct. That's what the Supabase docs say. If you Google get session and look at the response, you'll see that one of the options is that the session property of the data object would be null if there's no session in local storage. Okay, take it slow, one step at a time. Good luck. See you in a minute. Okay, I hope that went well. So we're going to go for async. Let's copy this function name. And then we're going to set up our try catch. There we go. And we're going to execute this auth.get session. So we say await because it's an async function. We use supabase and we use the .auth.get session method. Now we destructure data and error back. There we have it. Handle both Supabase specific errors. So that's this error here. So we say if there's an error back from Supabase, we're going to throw that error so that it's caught in the catch. Let's deal with the catch now. So we put error in here, and then we can reference this error for what we want to do with it. Well, just like we did in fetch metrics, let's console.error with a little message, error getting session. And let's use the error.message to be really clear. Did we do that? Oh, we actually got error there, so let's improve that by putting message there. Great, save dashboard. Okay, if successful, log the value of the session property of the data object. So that's going to be here. Here is if we have success. We're going to console.log, and it's from the data that we're destructuring here. So we do data, and we go into that object, and it's the session property. There we see we've destructured data, so we've got this object, and we need to go into that and take the value of the session property. And then also update the session state with that. So we can use our set session, and again, it's data.session. Number 5, call the new function below the function definition. There we go. So we've defined it and called it in this use effect. And then let me save, and we'll see that little quirk that I mentioned, that in the Scrimba console, it shows as undefined, but it's actually null. So hopefully, when you got to stage 6, you went into your browser's dev tools and you saw the console log as null. One more time, let me remind you, we initialized session as undefined, and then we want this get session method to update it to either null if there's no session in local storage, and with the data if there is. But obviously we have no current way of signing in, so we can't see that data yet. Fantastic. Let me delete all of this. So when there is a session, it includes lots of data. We get the actual access token that was sent from Supabase on sign-in. It tells us when this token expires, how long until it expires. It's got a user property with the email address, the unique ID that Supabase gives to the user. So let's briefly go into what this get session method does. So when it's called, it checks for local storage. If there's no token, it just returns null. If there is a token, it then checks whether this token has expired. If it's not expired, it decodes it and returns the session data that we just saw in that slide. If it has expired though, it will check for a refresh token. If there's not a refresh token in the JWT, then it'll just simply return null. But if there is, it then makes a new request to Supabase for the new token. If this is unsuccessful, then we just get null again. But if it is successful, then it stores the new access token and we get the session data again. This is all happening under the hood. You don't need to worry about it, but it's interesting to know nonetheless. And this JWT, it proves the user's identity and that user's permissions. So what's quite cool is that Supabase doesn't actually track who's logged in and logged out of your app. The JWT that it sends and is stored in the client, that actually proves that they're logged in and for how long, etc. So it's a stateless authentication system. Okay, brilliant. On to dealing with number 2, listening for any changes in auth state. See you in the next scrim. Now that getSession is checking for a session object in local storage after initial render, we now need to move on to our second task, listening for changes in auth state. We need to constantly watch out for this session object being created or removed. On first render, we need to start it watching for changes, a bit like turning on a radar or a security camera, or like that friend that keeps asking. Okay, so number 2 is going to use another Supabase client method called onAuthStateChange. This is set up a little bit different. We use the Supabase word, and then again it's another auth dot something because it's part of auth. And we've got onAuthStateChange, and then we pass to it a callback function that runs when some auth state does change. So let's set up this callback function. There we go. And the callback function receives 2 arguments, the event that causes this to fire and the session object. Now, if the event is, say, a logout, then the session object will be null. Do you remember? It's null if they're signed out, and it's the data from the session object in local storage if they're signed in. Because we're not actually interested in what event causes this, we're going to use a little underscore there. And then again, the whole point of this is to update the session state. So we use setSession again. And this time, we don't need to use data.session because we're getting the session directly. Here, remember, the session was in the data object. And then why don't we put a console log here so we know when some auth state does change. Session changed. So now our app is going to react immediately when a user logs in, logs out, or their session changes in some way. We get to respond to this change in real time, thanks to this .onAuthStateChange method. Okay, fantastic. Let's remove these comments now. And now it's time to learn a bit more about these JSON Web Tokens I've been going on about. See you in the next Scrim. Now to learn how Supabase remembers who we are when we're logged in, but also how the same JWT system has handled our anonymous requests up to now. Remember when you created the Supabase project at the start of the course? We used a project URL and an API key. The key is called the anon public key, seen here. We stored both the project URL and the anon key in our environment variables in Scrimba. Even though this API key looks like a string, well, plot twist, API keys in Supabase are actually something more sophisticated. They are JWTs, JSON Web Tokens, a way for securely transmitting information between parties as a JSON object. We can see here we have lots of numbers and letters and then a dot. Well, if you could see the rest of it, you'd see there are actually 3 sections separated by dots. The first section is the header, then we have the payload, and then the signature. I mentioned JWTs in the last Scrim when I said that Supabase issues a JWT when a user signs in. Well, all will be explained now. So to understand how this works, I have a metaphor for you. I've been back and forth on which metaphor is best. I hope this one works for you. Let's imagine that creating our Supabase project was building a beautiful grand castle, which can store anything we want. Each room is like a different table in the database. When we send a request to the castle, it's like sending the castle a letter. This letter might say, please add something to this room, please send me the contents of this other room, or please delete some of another room. You get the idea. The project URL is like the postal address on the front of the letter, to which castle or project it will be sent. Now, onto the JWTs. Let's think of this JWT like a certificate that is created by the castle. The first type of JWT we're going to talk about is this anon key that we mentioned earlier. It was created when the castle was built, and we've hung it on our wall in our client house out in the kingdom somewhere. Here we can see the anon key certificate over on the client side. So on the left here is the Supabase castle, and on the right, this is our client house somewhere in the kingdom. Stick with me on this. The 3 parts here in the anon key are represented here as the header on the left, That just has information on the algorithm that was used to create it, so we don't need to worry about that. The middle part is the payload, this scroll. This includes the claims of who we are and what permissions we have. And then the right symbol is the signature. And this is the part I'd actually like us to start talking about. So information in a JWT certificate can be verified and trusted because it is digitally signed. Continuing my metaphor, when the castle created this JWT certificate, it signed it using the castle's unique magic secret pen. The signature that was created is the proof of authenticity for the certificate. This magic secret pen is the project secret. See what I did there? In our Supabase backend. And you can find this if you look deep enough in your Supabase project. It's something we definitely do not want to leak, since anyone who has access to it can create new certificates and also verify existing ones. So when creating any JWT, Supabase uses this secret to cryptographically sign the first two sections, that was the header and the payload, of the token to produce the signature, the third part. And Supabase signed the anon key when it was created on project creation, and we've stored it in environment variables. Now, whenever we write a new letter or request from the client house to the castle database, we include a copy of this signed JWT certificate. The Supabase docs actually say that this anon key is for developers to send along with their API requests whenever they want to interact with their Supabase database. So we send off our letter with that project URL address on the front in the post. It arrives at the castle and the guards verify it by taking the castle's secret magic pen, and they use it to write a new signature based on the certificate's contents. They then compare this fresh signature with the one already on the certificate. If they match perfectly, they know this certificate was originally signed by our castle and nobody has altered anything since we signed it. They can say, yes, this particular certificate was signed here by our secret pen. It's come from a legitimate source and it hasn't been tampered with. If anyone had tried to change anything in the header or the payload, the signature wouldn't match. So in reality, Supabase takes the header and the payload, applies the secret key algorithm, and compares the result with the signature part of the JWT. The reason the key is called the anon key is because it's used by our front-end app to initialize the Supabase client and make requests as an anonymous, not logged-in user. We're about to get into that anonymous part now, okay? So the anon key proves it's a valid token for our specific project via that signature. So that was about that signature third part. Now we're going to go on to the middle part, the payload, this part here. So the payload is encoded using base64, which is a simple letter scrambling. For an authorized user, and we'll see this in the next scrim, the payload includes lots of details about the user. But for this anon key, you guessed it, it doesn't, since there's nobody logged in. But it does have one important piece of information. The payload has a part detailing the sender's role, and this is one of two values. It's either anon or authenticated. In our metaphor, this part of the certificate reads, "This is a public anonymous request," or "This user is a full-blown signed-in member." Up to now, when we've been making requests to Supabase, like our select or our insert for deals in the sales deals table, this anon key that Supabase created and we've stored in environment variables is sent to Supabase with a role of anon. Hence why it's called an anon key. It's like a basic visitor's pass, whereas a logged-in authenticated user's JWT is like a full member badge with specific permissions. Supabase knows which project or database to connect to, but the user is considered anon. This is like a public anonymous request. For a deeper dive, I recommend watching the CTO of Supabase talking about JWTs. Click the screenshot and you can hear from Ant as he decodes JWTs and shows how that signature is created using the project secret. Next, we're going to see what changes when a user signs in and Supabase issues them a full members badge JWT. See you in the next scrim. So you've heard about the anon key. Let's now talk about what changes when a user signs in. So continuing our metaphor, when someone new moves to the kingdom, they send their details to the castle to gain citizenship. This is like signing up. And Supabase stores their email and password. Then, when this person wants to interact with the castle, they send a letter to the castle with their credentials, their email and password. The castle checks their credentials against their records, and if everything matches up, the castle issues them a new JWT signed certificate. But this time, the role part of the payload will be authenticated, and there will be loads more detail in the payload about when the token expires, the user's unique ID number that the castle has issued them, and much more. This certificate is like a temporary member's pass that proves they are who they say they are. They then store this JWT certificate in their client house, and they must include this certificate with every future letter they send to the castle. And then let's try and push this metaphor one more step. When the user is done and they want to sign out, they send a letter to the castle saying they're done. The castle invalidates their current certificate, and they can no longer use that certificate for future requests. So they have to start the sign-in process again. So let's see that on this slide. So when they sign in, or actually at the same time as when they sign up, because signing up in reality actually signs them in at the same time, Supabase checks their credentials and issues a JWT certificate with a unique signature just for them, written with the secret pen. The middle payload part here includes their role of authenticated, indicating they're logged in, their sub, which is the unique user ID, the email, when the token's issued, when it expires, and other user and app metadata. And they've created their unique signature with the project secret pen. There we go, with role authenticated. And then here we have that JWT certificate stored in local storage. And then this part here creates that session object that we mentioned in a previous scrim. That would then trigger the on-auth state change. Remember this part here? This would then get triggered, and we use the session object and we update the session state variable. So the really nice thing here is that when a user makes a request to Supabase, they don't need to continuously keep proving who they are with their email and password each time, since they're including a copy of the JWT certificate, which does that for them. The JWT is sent in the request headers. Supabase extracts the JWT from the request. It uses the project secret pen to verify the signature. If it's valid, it knows the token was issued by this Supabase project. The token hasn't been tampered with, and the user's claims in the payload are authentic. Okay, thanks for sticking with me with that. I know it's quite a long explanation, but hopefully it will mean that you understand what's going on for the rest of the course. A quick challenge now. It's multiple choice, don't worry. I'd like you to delete the two options and leave your answer. So first question, which part of the JWT includes the role of either authenticated or anon? Second question, how does Supabase know the JWT is authentic and not forged? Third question, what does the JWT signature prove? Fourth, in our castle metaphor, what represents the project secret? And 5, what's the main difference between an anon JWT and an authenticated JWT? So remember, we talked about the anon JWT in the previous scrim, and in this scrim, we've been talking about the logged in authenticated JWT. Okay, good luck. Delete the two options and leave your answer, and I'll see you in a minute. Okay, I hope that went well. So number 1, which part of the JWT includes the role of either authenticated or anon? So if we look back at this, we've got the header, we've got the payload, and we've got the signature. Well, I told us not to worry about the header, and the signature, well, that was written with that pen, so it's our middle payload part. Okay, number 2, how does Supabase know the JWT is authentic? Well, it checks that the request was sent to the... Well, it's not to do with the URL. So let's delete that one. It verifies the JWT signature was created with the project secret. Aha. Yes, there we go. That's the answer. because the project has that secret pen, and the fact that the signature on the JWT certificate is the same as the new signature that Supabase creates when it receives the letter, it knows that it is authentic and it's not been forged. So it can't be C. What does the JWT signature prove? Well, a little bit similar to the last question, that it hasn't been tampered with and came from a trusted source. Okay, number 4. In our castle metaphor, what represents the project's secret? Well, it's not the guards, and it's not the actual certificate. That's the JWT. So yes, it's that secret pen, which signs the JWT and creates the signature, the third part of the JWT. Okay, what's the main difference between the anon JWT and the authenticated JWT? Well, the role field, yes, it's that middle part, the payload, the second part of the JWT, and the role field. All JWTs have a signature, and nope, there's only one project secret. There we go. Brilliant. I hope that makes sense. Do ask AI or have a Google if it doesn't. And now that we've done the theory, we get on to actually adding a user into our Auth.Users table and working on actually signing in a user. See you then. Now that we have the getSession method checking for the session object in local storage and the onAuth state change checking for any auth changes, we need to be able to sign in so that Supabase issues the JWT and the client library creates that session object. Supabase creates a users table in the auth schema when a project is created. Since we don't yet have functionality to sign up a user and add them into that table, let's manually add a user to this table now. So follow along with me and do as I do. I'd like you to navigate to your project dashboard. Here's mine. And then on the left, we're looking for the authentication part. That's the thumb up. It's the 5th icon down on the left. Click that and we should get to this authentication page. And immediately you see this Auth.Users table, empty of users at the moment. We're going to go on to the right and click the green Add User and then Create New User. And you should see this pop up here. Now, because of the Office theme, I'm going to add a user, Dwight. And my company is called Paper Like a Boss, so I'm going for dwight@plab.com. And to keep things simple, for my password, so I don't forget them, I'm just going to go for the name 3 times, which is Dwight, Dwight, Dwight. If you have another system, that's fine, but you may want to adopt mine. And then we definitely need to make sure that auto confirm user is clicked. Because this is not a real email address, we can't have an email going to it and a link in that email needing to be clicked before they can be confirmed. All right, great. And then green, create user, and here is Dwight in the users table. Supabase has automatically created them a UID. This is like a unique identifier for this user. Fantastic. So now we've got a user. Let's work on the signing component in our app so that Dwight can actually sign in to our application. See you in the next scrim. Okay, we now have a user in Auth.Users. So let's now work on our signing component so they can use the email and password and sign into our app. I've added some front-end code here in the signin.jsx component. It's looking like this now. We have a form, we've got an email and a password and a button. Just have a look down here. We've got a few comments to remind us what we need to do, like we need to add a link for this sign up here, and we need to add some accessibility and an error message at the bottom. But do pause and have a look through this if you want to in more detail. We're going to be using the new use action state hook from React 19, which we used for the new deal form in the last section of the course. Since I explained it and wrote it back then, now it's your turn. If you need a refresher, do click on this slide and it'll take you to that scrim and you can rewatch that. But if you're feeling confident, let's go. So we've got the action prop here on the form. That's important. And anytime you want to have a quick peek at when we used this hook before, you can have a little look in here. So I'm going to be asking you to set up the use action state hook, and then I'll finish it in the next scrim. Here's our challenge text then. So I'd like you to import the use action state hook. I'd like you to call the hook at the top level of our component, destructuring 3 values. We've got error, we've got submit action, and we've got is pending. Now, this is the state that we're controlling here. It's going to be the error if we get one back from Supabase, which we will eventually render down here in the error message on the UI. Submit action, that's the form action function. And then is pending is our loading state Boolean. Now we're going to pass 2 arguments to use action state. The first argument is the asynchronous arrow function with 2 parameters. And the second is the initial state value of null. Okay. Now, I've not given you these 2 parameters here, so you will have to either look that up, see if you can remember, or have a peek in form. And then inside the async function, I want you to extract the email and password into variables. So if we have a look down here, here's our email input, and then below, here's our password input. And then I'd like you to add the submit action to the form's action prop. So I realize this might be a bit daunting. Take it slow, either have a little look in form or bring up the slides. That's Command Y. And click on that link to watch a little bit of the previous scrim. Or use Google or AI. Good luck. See you in a minute. Okay, I hope that went well. Let's start it at the top. Let's import the hook at the top. Number 1, done. Call the hook at the top level of the component. Destructuring 3 values. Error, submit action, and is pending. Number 2, done. Pass 2 arguments to use action state. The first argument is an async arrow function. Okay, so we go async, here's our arrow, curly brackets, there's our async arrow function. And the second, the initial state value of null. There we go. Now, the async arrow function has to have 2 parameters. Now, we think back to when we did this before, and we remember that the first parameter is the previous state in case we want to use it in the function body. So let's call that previous state. And then the second one was that form data, the object containing all the form's input values. There we go. Brilliant. Number 3 done. Inside the async function, extract the email and password into variables. So we're going to be using this form data object now. So if we want to extract them in, let's make email and let's define password. And then here's where form data comes into play. And we use that .get, don't we? And then it's whatever we called these inputs. So the name of this input is email. And the name of the password one is almost certainly password. Okay. Number 4, done. Number 5, add the submit action to the form's action prop. So we can uncomment this now. And then let's curly brace this guy. Yeah, okay. So we're going to have to do a lot in this. So let's just put a comment here and say, well, the first thing we've done is extract the form data. Okay, fantastic. Challenge complete. Tidying this up. Okay, we're in a good place now. As you can imagine, we've got lots more to do with this email and password variables here, but I'll do that in the next scrim. So well done for remembering about the use action state hook. If you had to get some help, don't worry about it. It's all repetition, repetition, repetition. Okay, I'll see you in the next scrim where I'll continue where we left off. See you there. Okay, time to finish off where we left off here. So we've already extracted the form data. Let's put some more comments in as like a little to-do list. So number 2, we need to call our sign-in function. Now remember, we're going to be centralizing all of our auth functions here. We've not got a sign-in function yet, but we'll be doing that shortly. So we need to call that sign-in function here. We need to then handle any known errors from Supabase. And the important thing we need to remember about use action state is that it returns the new version of state. And remember, we're using state as an error. So whenever we handle any errors, we need to remember to return the right thing. So because we're handling an error here, let's just put in brackets here, return some sort of error. Then number 4 would be to handle success. And if we successfully sign in, then we want to be redirected. I'm going to also put return null because we don't want to update the error state because there's no error. And then number 5, we want to handle any other cases as a sort of safety net. In case it's not known errors or it's not successful, we need a safety net to make sure we return something. And then lastly, we're going to handle unexpected errors. And here we would return some sort of error. Okay, brilliant. Okay, let's use one of our try-catch blocks as well. So let's start the try here. And then we're going to be catching just above number 6. Okay, to help going forward, we're going to decide what we want to be getting back from this sign-in function that we're yet to write. So I'm going to decide by destructuring here that I want to get back a success boolean, the data if it's a successful sign-in, and also the error if there's an error back from Supabase. And let's call that error sign-in error. And we're going to put await because this is asynchronous and we don't know what this is called yet. So I'm just going to write sign-in function. And because we're going to have to be passing our email and password to it, let's just do that now so we don't forget. Now, the fact that we know that we're going to get this back is going to really help us. Because to do number 3, we can say if, and we know that the Supabase error will be called sign-in error. We're going to return, because remember we must return something to update this error state with. And let's use the error constructor. So we go new error, capital E, and we pass to it that sign-in error from Supabase. Okay, I feel like we may need to comment all of this so that we don't get any red lines. That's fine. Now, number 4, handle success. So how do we know if it's been successful? Well, we've decided that we want to receive a success boolean. So we can say if success. And we've said we want to redirect here. So let's just put navigate to, and it would be to our dashboard route. And then we need to remember to return null also. So we can get rid of that now, reminder. We can also get rid of that. So now let's just talk a little bit about the data we get back from Supabase on a successful sign-in. It's going to be in this format. It's an object with user and session properties. Now we already kind of know what the session is because that's what our get session or on all state change is going to be looking for and giving back to us. But this user property is just for convenience. Funnily enough, this user is actually included down here in the session object. But Supabase is just helpful and it puts it right here as a property of the main data that it returns. So the way we know that there's been a login success, we can use this success, but the real way that we know is whether there is a session object. So why don't we be extra careful and we say there also has to be data in data.session. Because remember, this would be the data and we have to go into it with the dot. Now, in the scenario, if sign-in fails and data is undefined because there's no data back from Supabase, let's use the optional chaining operator so that we don't get any potential runtime errors. Okay, fantastic. And then number 5, as a safety net, we can just return null. As I mentioned, in case any of these ifs don't return, we've got a sort of last line of defense there, safety net. And then we handle unexpected errors. So we can log this to the console with a little message, sign in error. And let's go for error.message again as we did before. Nice. And then we don't need to forget to return an error here as well. So we can actually almost do the same as we did here. We want a nice friendly error message that we can render in the UI. That looks pretty good to me. Okay, very nice. Let's get rid of these comments and spell this correctly. There we go. And then we can uncomment this when we finally write our sign-in function in auth context. Now let's finish off our accessibility in the return here. So we can't quite do the link yet, but we'll leave that for later. But let me type this out and then I'll explain it. So if there's an error, we've made ARIA invalid true. This is, remember, our error state from useActionState. Similar thing with ARIA described. If there's an error, we're using signed in error. And then we're disabling this if is pending, our sort of loading state is true. Totally the same on the next input. So I'm just going to copy and paste that. Just finish off this class name and ARIA busy. And then let's do a little bit of conditional rendering here. There we go. We probably won't even see this because it'll happen so fast, but it's good to have anyway. And then a quick error message. There we go. So if there is an error in that error state, then we'll just log the error on the UI. Great stuff. We should be able to check that that error is working. If I just use any old random stuff here. There we go. Brilliant. We get the console log and we get our error message just below the button. Very nice. Next up, we're going to be writing this sign-in function in our auth context central file. See you there. Now that useActionState in sign-in is almost complete, we need to write this sign-in function. Because we decided this is the response we want back, let's copy that over to auth context. So sign in, and let's just put this here as a reminder. So currently we're passing session through our app via context, but we are going to be passing all of our auth functions through context so that we can access this sign-in function we're about to write here. So my plan is to write it all out for you, and then in the next scrim, I'm going to delete the Supabase client method part of it and get you to do it again. So you get some time with your fingers on the keyboard. So we're going to call this function sign in user. Very original. And it's async, and we'll be getting the email and password from the sign in component. Now let's do a try catch block again. We're getting quite good at these. There we go. And let's put some comments in as we're getting accustomed to. Handle Supabase error explicitly, then success. And then in here, we're going to be handling unexpected error. All right. So we're getting pretty used to this now. We say await, and we use the Supabase client word. And similarly to up here where we use .auth something, we're going to do the same thing. .auth. Now there's lots of ways that Supabase lets people log in through OAuth, SSO, with a magic link or one-time password. We're going to go for the trusty password. So the method is sign in with password. And we pass to it an object with email and password properties. Now the email we're getting from here, but in case the user has added any uppercase letters in their email, we want it to be consistent in our database table. So we're going to use our .to lowercase. There we go. And the password is going to be just the password. There we go. Okay, that's the part you're going to be doing yourself. So have a good look at that. Now, Supabase errors. You know what? I've totally forgotten to destructure any response. So let's do that now. And we're used to getting data and error back, aren't we? The responses back from Supabase are always very consistent. That's one good thing about Supabase. So the Supabase error is this error here. So we can say if there's an error at this point, we're going to return, and we know the format. Success is obviously going to be false. And the reason I'm doing an object is because, remember, we destructured this from an object. So let's make sure this is spelled correctly. And then the error part of it will be the error here, which is from Supabase, and we want the error.message to be nice and explicit. And then we probably also want a console.error. Let me check. Did we do one here for Supabase error? No. Great. So let's do one here. Supabase sign in error. Okay, very nice. Next, on to success. So if it's successful, we want to return, can you guess? Well, the success property of the object is obviously going to be true. And we don't need to bother with an error part, but the data is important. So let's put data. We don't need to put data is data. We can just purely put data like that. And why don't we put a console.login so that we know if it's successful? Supabase sign in success. And let's get the data so we can see it. I have already told you that it should be in this format, shouldn't I? But we can prove that in a minute. Okay, success done. Supabase errors done. Now just the unexpected errors down here. So we want to return, well, very similar to this actually. We can probably just copy this. And let's have a look at what we did here. So we did console.error here. I think we need consistency, you know. So let's remove it from here. And then let's put a console here. And let's be a little bit more explicit here. Unexpected error during sign in. And the error here can be an unexpected error occurred. Please try again. Oh, error disappeared. There we go. Now I'm thinking we may have some redundant handling here. Yes. So because the unexpected error is already being caught in auth context, I don't think we actually need a try catch in sign in. Nope. I've changed my mind. It's a bit redundant. So I'm just going to get rid of that quickly. There we go. That's better. We're doing all our consoles, logging and errors here. Unexpected error is being dealt with here, and we're returning this message, which we will then catch here. Okay, brilliant. So let's test this, and then it'll be your turn. So I mentioned that we need to now pass this new function to the value object here so that we can access it through context. Save this. We hop back over here, and we need to now import our custom hook. There we go. And we're going to go back one level into the context folder, and it's called Auth Context. There we have it. And then right at the top of our component, we're going to destructure from the object, and it's our new sign in user function. There we go. Now sign in user is available. So we just need to pop it there. Get rid of this comment. Brilliant. Let me save. Great. So let's test this. My email and password is going to be extracted. It's going to be passed to the sign in user function. The response we get back from that is here. And the way we're going to tell whether we're successful is we've got this console log Supabase sign in success. We'll hopefully see data. And of course, when we sign in, we know that the JWT will be sent from Supabase, and the client will take it and create that session object, which our lovely on state changed will see. Remember, it's that CCTV or radar. It'll see that and then return the session, and we'll set our session. Cross fingers. Bingo. So there's no error. Let me just minimize this a bit. Let's open up our console. Yes, we see session changed. That's from on state change. And we see Supabase sign in success. And it's the way I mentioned it. It's an object with a user property and a session property. And look, the user property has got that unique ID, the UID that we saw Dwight being given in the Auth.Users table. It's got the role of authenticated. That shows that the user is logged in. And it's got the email they used to log in. The Scrimba console doesn't actually show us everything. So in the next scrim, when you test it after you've completed the challenge, why don't you look in your dev tools and you'll see the whole session there. Great, so this is working. In the next scrim, it's going to be your turn to recreate this and show off your skills. See you then. Okay, time for you to show me what you've got. I've deleted the top bit of the try, and it's your turn to make an asynchronous call to Supabase to sign in with a password. If you're not sure the syntax, have a look at the Supabase docs. The better you are using the docs, the better you will be with using Supabase. Passing an object with the email, remember we need it to be in lowercase, and the password, destructure the response into data and error variables, and then save and test by signing in the user that you added manually into Auth.Users. As I mentioned in the last scrim, if you want to see the whole session object, I recommend going into your DevTools, F12, and looking at the console there, and you should see lots of data. Good luck. See you in a minute. Okay, I hope that went well. So in the try, let's destructure those two data and error variables. And we use await because it's asynchronous, and we say supabase, and because it's auth, we use auth dot, and the method we need was sign in with password. And then we pass an object, and that's got an email property and a password property. And the email, we need to make it lowercase with dot to lowercase. And the password is simply the password. Okay, that's it. Save. Get rid of the challenge text. And let me try again. There we go. No error. That's a good sign. And we look again. And there's lots more in here. Session changed. And Supabase sign-in success again. Fantastic. That is working. Get rid of this now. It's pretty obvious that it's the sign-in function. Brilliant. Now, because all we can do is sign in now, you might wonder what happens if we keep signing in. Well, basically, when you log in, Supabase issues that access token JWT and a refresh token, and they're stored in the browser. If you log in again with the same credentials, Supabase just replaces the old token in storage with the new one. The previous session in the browser is simply overwritten, so you remain logged in as the same user. And a good thing to know is if you log in on different devices or browsers, each will have its own set of tokens and session. Supabase does not invalidate previous sessions by default when you log in again elsewhere. All sessions remain valid until they expire or you explicitly log out. Okay, fantastic. We can log in now. Let's work on navigating here to dashboard. See you in the next scrim. Now that we can sign in, let's learn about navigate and link. When we have a successful sign-in, we see here we need to follow this arrow and get to the dashboard route, which is going to render the dashboard component. So we've got this comment here, navigate to dashboard. Let's finish that bit now. Navigate is a function provided by the useNavigate hook from React Router DOM. I'm going to import it at the top. And it's from React Router DOM. And then because it's a hook right up here with use auth, we're going to say use navigate. And then React Router provides this function for us. So we say const navigate. There we go. We can now use this navigate function. So down here, we can replace this and we just say navigate. And we pass to it the path that we want to go to, which let's have a quick look in Router. It's going to be /dashboard. Okay, let's save. Okay, now we can test. Hopefully when we sign in, we get navigated to the /dashboard route. Fantastic, there we go. And we see Supabase sign-in success. All right. Next, we're going to move on to linking from sign-in to a new sign-up component I've just created. So let me navigate back to our home route. And you can see here I've created a new signup.jsx. It's very similar to sign in. The only difference is that we have the word sign in, we have different form description, but you can see all of that's very similar. So it's a challenge time now. In Router, I'd like you to create a new route for this sign-up component. Here we are. So I'd like you to create a new route with path /signup. Set the element as the signin.jsx component. Remember, that's not been imported yet. And then save and test your path by navigating to /signup in the mini browser. Good luck. Okay, I hope that went well. So why don't we just copy one of these objects? There we go. And it's sign up this time. And the component is sign up, not sign in. And we need to import it. It's going to be very similar to here. So why don't we just copy that and modify it. There we go. Save that. And I'm going to test it by navigating to sign up. And there we go. It says sign up today. And we have the link eventually back to sign in and sign up in the button. Lovely. Now let's work on linking between these. So let me go back to sign in, which is our home route. We need this sign up to be a link to our new sign up component. And here it is in the code. We're going to use a link component. This is also from React Router DOM. So let's add it to here. And it's a component, so we're going to wrap it around the sign up word. It's a component, so we need to remember capital L. I'm going to give it a class name of form link. And then the other side of this, we need our closing. There we go. Now link, it renders as an A anchor tag in the DOM, but does not cause a full page reload. Instead, it updates the URL and renders the new route instantly using JavaScript. So this is not quite finished. We haven't told it where we want to link to. So we add a to prop, and then we write in the path. So let's have another look at this. Remember that our sign in can link to sign up. And in a minute, I'm going to get you to do the other way, link back to sign in. So we want to go to sign up. Okay, I'm going to save. And now we've got our nice green link. And I click to it, and there we go. We re-navigate to /sign up. This isn't a link yet. This is what you're going to finish off now. So over in sign up, here is another challenge. Wow, I do work you hard, don't I? I'd like to import the link component from React Router DOM. Turn the sign in, so that's all the way down. I missed it here. Into a link which routes back to sign in. Add the form link class to the link and save and test your link. Now, if you need to know the path for this, check our router.jsx. Because remember, the sign-in component is not rendering in the /sign-in path. Okay, remember, if you need to see the slides, you can use a command Y or control Y. Good luck in this challenge. I'll see you in a minute. Okay, I hope that went well. So at the top, we're going to import link from React Router DOM. And we're going to turn this into our link. And we need the class name, and we need the to. And we leave that blank for now until I finish the closing. And then we're just going to push that forward. Very nice. Okay, so we've done this, which routes back to sign in. Now, sign in was in our home path, wasn't it? Yeah. If I look at this again, user visits home and they see the sign in page. Okay. So it's a simple slash for the home path. Have I finished everything? Yep. Okay, get rid of the challenge text. And we can save. And yes, in our sign up component, we see the sign in link now in green. We click that and we go back to our home path. So we can just keep going back and forth. Okay, brilliant. So our navigate to /dashboard on successful sign in is sorted. And we can now link between our paths of home for sign in and /sign up for sign up. Let's work on being able to sign out now. See you in the next scrim. We can sign into our application now, so I guess the logical thing is to now work on signing out. We're going to start this time by actually writing the auth function, and then we'll move on to dealing with some sort of sign out button. So here's the section of auth context, our centralized file for all the auth functions. We've done sign in. Underneath, let's go for our sign out. Now, so that you get lots of practice, it's challenge time. So using the sign in function as a template, write a sign out function calling the auth.signout method this time. So remember up here, we used the auth.signin with password method. This time we're going to be using auth.signout method. The best thing to do here would be to look it up in the Supabase docs and have a read about it. We only need to destructure error because here, remember, we destructured data and error because we wanted to see the data we get back from Supabase. But when we sign out, we're not interested in any data back. We just want to know of any potential errors. And of course, if we scroll up, our on-auth state change CCTV radar will pick up this sign out and update the session state variable accordingly. Well, we actually know what will happen to it because we know that if the user is signed out, it will always be updated to null. So this time, instead of we're going from undefined to one of these, we went from undefined to null earlier, but now we are signed in and we're working on signing out, so updating the session state back to null. Okay, handle both Supabase and unexpected errors in a similar way to in the sign-in user function. So you could do a copy and paste here because, again, we're going to say if error from Supabase, we want to console.error it, and we want to return exactly the same thing because we still want to use this success property of the return object and an error if it's needed, but we will not need to use the data because that's not what we're destructuring back, okay? Add this function to the auth context value prop. So remember, when we finished the sign-in user function, I added it here so that we could access it through context. When you finish your new sign out function, you can add it down here so that we can access it wherever we're going to have our sign out button. And then a little note here, there is no need to pass the Supabase sign out method any parameters. Remember up here, we obviously passed the sign in with password, the email and password, but we don't need to do that with this auth.signout method, okay? So take it slow. You will actually be able to basically change just one word here. So it's sign out, unexpected error during sign out, but do use this function as a template, okay? All right, good luck. See you in a minute. Okay, so let me be a little bit lazy and I'll copy this. So we're calling it sign out instead. We don't have email and password here. I said only destructure error, so we can get rid of data. And it's the sign out method. So we can actually take all of this and replace it with that. If error, console.error, yep, Supabase sign out error this time, isn't it? And we can log the error.message. Again, it's going to be success false, and we want to return that error message. And then this is our success, but because we've got any data, we don't really need to log it. Another reason why we don't need to log it is because we will see the session change here. So we'll know whether the logout has been successful. Let's get rid of data. There we go. We catch any unexpected errors, and then we say unexpected error during sign out. And we return success false, and unexpected error occurred, let's say, during sign out. Okay, that looks good. And then number 3, add this function to the auth context's value prop. So we just add it to this nice object here. Now it's available through context. Super. Get rid of this challenge text, and we don't need that because it's called sign out. So we know what's happening here. Great. I'm going to save. So when this .signout gets called, the client library deletes the user's JWT, the access token, and the refresh token from the browser's storage. That can be local storage or cookies. And then, as I mentioned, our on-auth state change listener will receive the change and update the app's session state to null. In a minute, we're now going to write a function when a sign out button is clicked, which will then navigate back to our home path. Okay, thanks for your help with that. Now let's deal with the sign out button. So I've actually added a button here. I'm so efficient. Let me show you that. There we go. So I'm now going to work out how to get this working. So let's start by accessing the sign out function that we just wrote. So we need to import the hook. We're getting used to that now. It's our use auth hook. and it's from auth context. So we go into context. There we go. And then right at the top, we call it and we destructure the sign out function. Okay, so that's now ready to use when we need it. So we're getting an error back from here, aren't we? Let's store that error in some state. So let's import useState, and we'll create some state for the error. And it can start off as null. And then let's write a handle sign out function. Okay, we need to remember it's async, and we're going to take the event parameter so that we can do our e.prevent default. And before we forget, let's add our onClick to our button. And it's going to be this handle sign out function. There we go. And then here we're going to call that sign out function that we are accessing through context. So we need to use the await, and we call sign out. And we need to destructure the response. What do we get back? Well, success and error. No data, remember? There we go. Very nice. And let's just do an if statement and an else. So if there's success, then what do we want to do if there's success? So we're signing out. We want to go back to our sign in component, which is, who can remember? Home directory. So we're going to navigate to home. And then if there's not success, we can set our error state so that we can render it in the UI. So we use our set error setter function, and we update it with the error. And let's, for consistency, go for error.message. Okay, very nice. And let's now put an error message in. So let's put it just after the button. We're going to use some conditional rendering. So we're going to say if there's an error, and we use the double and we say we want to render then a div, and it's going to have the alert role, and it's going to have a class name of error message. It's going to have an ID of sign out error, and we want to render the actual error, and then we'll have a closing div. Okay, we've saved that. Okay, so a way to check the error is if I just change this from null to failed to sign out. We save that and we see that over there, failed to sign out. Okay, great. So the error's working, and we can actually test the button as well, because if we click it, hopefully we'll see in the console information about the session change. We won't actually navigate. Yes, there we go. See session change to undefined. So we know that the button is working and firing our sign out auth function, which is signing us out of Supabase. The client library is deleting the user's JWTs, and our on auth state change is noticing the session change and using set session to update the session state variable. Okay, in the next scrim, we're going to be navigating back to our home path here. And I'd quite like to also show the email of the user who's logged in up in the header as well. That's going to help us understand what is available in the session that we are passing here through context. See you in the next scrim. Okay, so we can successfully sign out. The client library deletes the user's JWTs from the browser storage, and after the tokens are deleted, our on-auth state change listener will receive the change and update our app session state accordingly. Let's deal with our navigate back to the home path here. Since I've already done a navigate for you, it's now your turn. After a successful sign out, when success is true, use the use navigate hook to redirect the user to the home route. Save and test this functionality. I'm going to take us back home. So that means to test this functionality, you're going to have to log in and then click the sign out button and check whether you get re-navigated back to the home path. Good luck. Okay, I hope that went well. So to use the use navigate hook, we're going to have to import it. There we go. And then because it's a hook up here, we're going to go use navigate. And remember, we then get the navigate function. There we go. We can now use that navigate word here. and we pass to it the path that we want to go to. There we go. Okay, let me save and test this. Let's log in as Dwight again. Okay, fantastic. And then I click log out. Yes, we see the session change in the console and we're back to home. Great, let me delete this. So this is the first of two ways we're going to make sure a signed out user will be directed back to the home path. In a future scrim, we will protect our /dashboard route by only letting users access this route if there is an active session. This means when a user logs out and the session is removed, they will be redirected back to home. I mentioned in the last scrim that I'm keen to show the email address of the logged in user in the header. So let me sign in again. I'd like to add it next to the sign out button. How are we going to access this? Well, we are passing our session object, and we've seen before that the session object includes a user property, which has their role authenticated if they're logged in, and their email. We saw this in the console previously. So we can access the email through here. So we need session in header. So we've already got the use auth hook, so we can actually add to this destructuring and say session as well, please. Let's log this session to the console and see what we've got. Actually, let's not go for session. Let's go into session and see the user property. Here we go. We've got the ID. That's the unique ID that Supabase gives every user. Role and AUD, very similar, both authenticated. And there's the email. That's the email we want to render in the header. So that's important. Let me copy that and we can delete our console log. And where are we going to put it? Well, actually, let's put it before the button. Going to make an H2 and a span. Let's write some accessibility as we go. So we've got an SR only class name, and that's going to say logged in as. And here's where we're going to render it. So we've got session.user, and we want to go into the user property and get the email. And you know what? Let's have the error after the email address. So it goes email, potential error, and then the button. Now, just for safety, because session is initialized as undefined, so that we don't risk any runtime errors, let's add the optional chaining operator after session and also after user. Okay, let's save. And thanks to some sneaky CSS, we've now got the sign out button on the right and the email on the left, and then nice space for any error message in the middle. Fantastic. So the user now knows who's logged in themselves. Brilliant. Now on to learning about a really important part of Supabase, or any database really, and that's row level security. See you in the next scrim. Time to talk about row level security. So even though we can't be navigated to our /dashboard route from our home path, users could still try to access dashboard directly via the URL. So if I type dashboard here, problem. So I'm not logged in right now. I'm not authenticated. So this is a safety issue. Our fetch metrics function has run to access the data for the chart, and that data has been sent. But if we remember, because I'm not logged in, my request is being sent with the anon key, which has that role of anon. If I was logged in, it would have the role of authenticated. So remember my earlier metaphor that JWTs are signed certificates sent in the request letters to our project's castle. Well, if this anon key with this role anon is a bit like a visitor's pass, and a full logged in authenticated role is like a full employee badge, then row-level security policies are like the bouncers stationed at each room or table's door, each bouncer following specific orders about which letters, requests, they should allow through. These orders tell them to check the sender's certificate, JWT, and the contents of the letter, the request, to determine if access should be granted. For example, a bouncer might be instructed to only allow letters from authenticated citizens who are requesting to view, say, their own data, or to allow letters that are adding new items to a specific room, table, if they come from users with the right permissions. So each bouncer RLS policy has their own set of rules that they follow to decide whether to let a letter through the door based on who sent it and what they're trying to do. So right now, because we have RLS disabled, even requests with this anon key, with the role of anon, are being allowed through the door of the sales deals table. We need a bouncer there to check for a full employee certificate with that role of authenticated, i.e. somebody who is logged in. So what is RLS? Well, it allows you to define policies which control access to individual rows in a table. So an example of this could be a sales rep for our app can only see their own deals, not everyone's deals. That's not something we're going to be doing, but you could implement that. It restricts access to authorized users. So you can say only users who meet specific conditions can access their data. An example, only authenticated users can view the sales deals table. This security is at the database level. It's enforced directly in the database. It can't be bypassed by the application layer, and it's more secure than application level checks. Policies are executed every time the table is accessed. So each time a letter gets to the door, the bouncer will check it. And it happens automatically. There's no need for us to remember to add any security checks in our code. The default is to deny. So when RLS is enabled, all access is denied by default. So you can imagine all of the bouncers get brought together and are told by their manager, RLS is going to be enabled. And they all get to their specific doors and they stand outside them and they don't allow anything through unless they get specific policies, instructions. Kind of like a full lockdown. And they're context aware and flexible, meaning that policies can use the current user's contexts, like their unique ID I've mentioned, to make decisions. And you can have different policies for different types of operations. So for a select query, an insert, an update, or a delete. What can we write policies based on? The JWT. So Supabase gives us these little helper functions, Auth.UID. When we write the policy, that returns the unique ID from the JWT. Auth.JWT returns the whole JWT, so you can go into it a bit deeper. Auth.role is that role of either anon or authenticated, and auth.email is fairly obvious. We can combine these with database queries, so we can check additional conditions or relationships, and the data being sent. So imagine an insert query. The policy or the instruction for the doorman can be check what's trying to be inserted, and there can be conditions on that. So combined gives you really flexible, powerful security rules, and the world is your oyster when coming up with these. Okay, that's enough theory. In the next scrim, we're going to be turning RLS on and writing a policy. See you then. Okay, let's enable RLS and write our first policy. So when we created sales deals, we turned RLS off. So we now need to turn it on. If you could follow along with me here, if you could navigate to your project dashboard, here's mine, and the same place we went to when we added a user to Auth.Users, we need the thumb up authentication part, which is the fifth icon down on the left. And then on the left underneath configuration, we're looking for policies. Here's our sales deals table, and it says a warning because it's not great to have this disabled. So we are going to click Enable RLS. And again, this is going to lock down all the data by default. And then we're going to write a policy to limit any interaction with our data to only those who are logged in or authenticated. So we confirm it with the green confirm. And then on the right, if you could click Create Policy, that should take you to this screen. So it's going to ask us for a name. It already has our table there because we've asked it to create a policy on this table. So I'd like you to add the name Authenticated Users Only. You don't need to touch the table. Permissive is the default policy behavior, and that means we're allowing requests with these details that we're about to put in here, okay? To start with, we're going to write a policy for all commands. So if you click all on the right here, I mentioned you can specify a particular request, but we're going to go for all now, quite a broad policy. And then at the bottom, if you could untick use check expression. So we should be looking like this. And then this using clause is really important. We're saying people who have a role on their JWT certificate of Authenticated are allowed access to the sales deals table. So we do that using Supabase's function auth.role. That returns the user's role from the JWT, and we're saying that has to equal authenticated. Remember, role is either anon for an unauthenticated request or authenticated. And this is actually a Postgres role. So I mentioned that permissive is default. You can write these as restrictive. That's the opposite. It denies access if this condition is true. But we are allowing access if this condition here is true. Another way we could have written the using is instead of using auth.role, we could have used auth.uid. We could have said auth.uid is not null. The reason this would work is because only authenticated users would have a UID. That's that unique ID that Supabase gives every user in the Auth.Users table. We saw it on Dwight in my project. So they would have worked the same. Here we're saying the role part of the JWT has to be authenticated. We could have said the UID part has to be something, i.e. not null. So now if we try and make any request to sales deals and we're not logged in, i.e. we have a role of anon, it should not allow us. The bouncer will say, no wait. Okay, click the green save policy. So now we have this RLS around the database. And the bouncer has been told, allow any action on sales deals to authenticated roles only. So here is the JWT being sent and the request. So this is the full letter. The JWT, remember, is the certificate that proves who is doing the requesting. And in the request, it might say what they're doing, to which table, what data might be being inserted, and how. So if the JWT has a role of authenticated, then the door will become unlocked and the bouncer will allow the letter through. So another example of a policy based on the data being sent, inserted, could be this one. Allow authenticated roles to insert their rows into sales deals. So their own rows, this means i.e. the name of the row being inserted has to be the same as their name, the person doing the inserting. Not that we have a name part in the JWT. Remember, it's only their email, their unique ID, and their role. So this might foreshadow an issue we're going to come across later. Maybe there's a better way to identify the deals in sales deals, maybe by their ID. Currently, remember, we have name and value in the sales deals table. Have a look in your project if you want. But maybe that's not a great way of identifying whose deals is who with the name, because currently in our database, we don't have names stored. There is a name obviously in the email, but I'm not sure how secure that is. Anyway, I'm getting a bit ahead of myself. So if any request does not satisfy the bouncer, it's not getting through. Okay, it's time to test. So now if I navigate to dashboard again, not being logged in, we do get there, but there's no data. We see in my dev tools, in the network tab, I see a 404 not found. But if I now go back to our home and I sign in, meaning that the request to sales deals will include a certificate with role of authenticated. Fantastic, there we see our data. So the RLS bouncer has said, let's have a look at your certificate in that letter. Yep, it's got the correct role. You're welcome to take all of the data. Okay, brilliant. I hope that made sense. I recommend reading up more about RLS in the Supabase docs and elsewhere. Okay, next up we're going to be working on a redirect from our home route. If a user's logged in, we want them to always be directed to /dashboard. See you then. Now that we have RLS protecting our sales deals table, let's talk a little bit about our routes. This is the current situation. The flow is a user visits the home path, they see the sign-in page. If they have an account, they'll enter their credentials and then a session will be created and they'll be navigated to the dashboard route. But what happens if somebody's logged in and they manually navigate back to home? Well, currently it's just going to show them the sign-in page. That's not ideal because they don't need to sign in, they already are signed in. Let me show you this now. So let me sign in as Dwight again. Here we are. And if I now navigate to home directory, We're back to the sign-in component, but we do have a session. We can see that in the console there. So we need a redirect that checks whether a session exists, and if it does, always redirects the user to /dashboard. So we want it to look like this. After the user visits home, we're going to have a root redirect, which checks if there's a session. If not, we go to the sign-in page as normal, but if there is, it immediately goes to dashboard. That means an authenticated signed-in user is unable to see the sign-in page. Only when they log out and a session is removed, they will then see the sign-in component. So every time the user visits home, the app will ask, okay, let's do this together then. So let me just sign out again so that we're back to our starting position. There we go. Now I'm going to create a new file in roots, and I'm going to call it root redirect. Let me just write out the boilerplate. There we go. And because we're checking the session, we need to import our custom hook so that we can get the session through context. There we go. And then up here, we're just going to destructure the session. There we go. Now the logic is going to say, if session is, well, let's have a look in auth context and remind ourselves that we initialize session as undefined. That was our loading state. And then get session will either set it to null if the user is not logged in, or with the session object data. So we should really have a little check here whether it's still undefined and hasn't been set yet. So before get session manages to check for the session object, we want to return a sort of loading. This is going to happen so fast we probably won't even see it, but it's good to have nonetheless. Just do a little loading div, okay? But if that's not the case, then we need to work on, let's have a look here. So yeah, if session's null, we want to see the signing component. And if there's data in the session, we want to go to /dashboard. Let's have another look at our slide. Okay, so as it hits this file, no session, i.e. null, go to the sign-in page, and if there is a session, we go to dashboard. Brilliant. So how could we do that? Well, why don't we use our question mark? So we've got session question mark, and then we'll have our colon. So this left side of it will be if there is session data in there, and we're going to want to navigate to here. So because we want to render a redirect as part of the component's output, we don't use the use navigate hook here. We actually use navigate with a capital N. And it's again from React Router DOM. So this, okay, is for declarative navigation. Whereas use navigate that we used, do you remember in sign in? That's for imperative navigation. When you want to navigate in response to some event or action. So here we have a programmatic navigation after successful sign-in. So we use navigate from the use navigate hook. Whereas here we want to render a redirect as part of our component's output. Typically these are used in conditional rendering scenarios, and that's exactly what we have here, okay? So it would look like this. This is a component, so we use our angle brackets, and we have a capital N, and we use a 2 to say where we want to go. And we can copy this and put it the other side of the colon. So if there is data, we want to go to /dashboard. So I can copy this in here. Now, if there's not, I want to see the signing component. Now, if we look at router, signing component is home. So that's not going to quite work, is it? Because if we look again at our slide, home needs to render the root redirect that we're writing at the moment. So we're going to need a new path for sign in. So I'm going to get you to set that up in a second, but let me finish this. I am going to use the path that we're about to code. So it's just going to be called, funnily enough, sign in. Doesn't exist yet, but it will in a minute. So we can get rid of this. We can get rid of this as well. Do read up about the difference between navigate the component and the use navigate hook that we used here. Okay, this looks good. Let me save. And now it's your turn to update the router file. Here's the challenge text. So I'd like you to update the route path to use the new route redirect component that I just wrote. I'd like you to add a new route for /signin that renders the sign-in component. And then in header, I'd like you to update the navigation. Let's have a look at header. Oh yes, our navigation now on sign out, we can update that navigation to go straight to sign in. Let me just change this to save and test. That when signed out takes you to the sign in path, and when signed in takes you to /dashboard, i.e. redirects you there. Okay, good luck. I'll see you in a minute. Okay, I hope that went well. So we need to import our new route redirect component, and it's in the routes folder. There we go. And I'm going to copy this, add it there. So we need to update home path to use the route redirect. There we go. Add a new route for /signin that renders the sign-in component. Bingo. Let me save this. And then in header, update the navigation to sign in when the user successfully signs out. So on a successful sign out, we now need to be redirected to sign in. Great, save that file. We can test. So if I go to home, I immediately get navigated to /signin. And if I log in, I'm now at /dashboard. But if I go back to home, it redirects to /dashboard. Fantastic. And let's check our sign out button. Takes me back to /signin. And let's check that sign up works. Yes, we can keep going back and forth between those two routes. Well done. Let me get rid of the challenge text. Okay, fantastic. Another job ticked off our list. Next up, we're going to be protecting our dashboard route so that only authenticated users can get there. Remember, our RLS is stopping us seeing the data fetched from sales deals or stopping us adding if we're not logged in, but we can still get there, can't we? Let me show you that here. If I navigate to dashboard, I can still get there. So we want to protect this route so that only authenticated users can get here. That will mean the RLS is like the last line of defense for the data, but we'll have check in our application to make sure only logged in users can even access /dashboard. Okay, I'll see you in the next scrim. Let's learn how to implement a protected route. If a user navigates straight to /dashboard at the moment, the server-side RLS stops the data being fetched from the sales deals table in our chart, but we can access /dashboard. This is obviously not secure. We did not log in, so we are unauthorized. We want to protect this dashboard route so anybody who's not authorized can't access it. We can see that RLS is like a last line of defense. Okay, let me take us back to our sign in. So we currently have this setup. Route redirect is checking when a user visits our home path. It directs them to /dashboard if there is a session and to the /signin if there's not. But as I just demonstrated, anybody could manually type in /dashboard in their URL and access it. So we've dealt with users visiting our home path, just /, but we've not dealt with protecting the /dashboard route if they navigate there. We can protect this route on the client side by adding some UX protection, a protected route. Because a user might close and reopen their browser, or the session might expire, or they might have bookmarked /dashboard. We need this extra check whether a session exists. Our route's going to sort of wrap /dashboard and check the authentication state. If session is still undefined, i.e. get session hasn't updated it yet, then we'll show a loading state, a little bit like we did for route redirect. We probably won't even see this, but it's good to have nonetheless. If there's no valid session, it'll redirect the user back to sign in. If there is a valid session, it will render the protected content. And our protected content for /dashboard is the header and the dashboard components. So I'm going to create a new file in the components folder, and I'm going to call it protected root. It's going to be so similar to this, so I might be a bit naughty and copy and paste just for the boilerplate part of it and the imports. So remember, we need to check the session again. So we'll keep that bit here. And again, we're going to show a loading div if session is still undefined. Now, this is actually a little bit of a learning opportunity because remember I mentioned there was a little quirk in the Scrimba console. I said that we initialize session as undefined. We'll update the session here either to null if there's no session, i.e. the user's not logged in, or with the session object data. But if we look at the console, it's still actually showing as undefined. And if you look in your browser dev tools, you will see it as null. But if we now think about the logic here, if the session was indeed staying undefined like the Scrimba console tells us, then we would constantly be seeing this loading div in a minute. And we probably won't even actually see this because getSession updates the session state so quickly to either null if not logged in, or with the session data if the user is logged in. And we're going to put another return here. And let's put some comments like we're getting used to. So if no session, navigate to /signin. If session, we're going to render the children. Now, the reason I've said children is because I'm going to get you in a minute to wrap the header and the dashboard components in this protected root. So we're going to import it here, wrap it, and because it's going to wrap around it, that means the header and the dashboard components will be the children of this protected root. And we can then render those children if there is a session. Okay? So we're going to receive children as a prop, and we destructure. There we go. So let's use another ternary. We'll say session ? And we're going to render these children. And then colon for if there's no session, and that's just going to be our navigate to sign in. I've already got navigate actually from before. So this is a component, and we use the to, and we say to sign in. There we go. Get rid of these comments. So when React renders protected root, it will receive these children as a prop children. If the user is authenticated, protected root renders the children. And if the user is not, it navigates back to the sign-in root. So another challenge for you. I'd like to import the protected root in here, wrap the header and dashboard components in the protected root component, save and then navigate to /dashboard in the mini browser to test the protected root. You'll know if it's working because if you have not logged in, you will not be able to access /dashboard and you'll be redirected to /signin. You can then sign in and check that you can still access /dashboard and see the header and the dashboard components. Because you're wrapping here in number 2, just think about what you're going to need. A little bit of a hint there. Okay, good luck. Okay, I hope that went well. So we're going to import the protected root up here. And then because we've already got these, we could actually use them. Let's copy this so I don't make any spelling mistakes. There we go. So now you can see header and dashboard are the children of the protected root. Save that. Let's get rid of here and we can test. So if I navigate to /dashboard now, there we go. We can't access it now. So we've got that UX protection as well as RLS on the actual table in the database. Let me check that I can still sign in and access /dashboard. Yes, I can. Fantastic. So because there is a session now, it's rendering the children. And I can still sign out. Okay, fantastic. So we are now set up like this. We've got root redirect dealing with the home path, and we've got our protected root dealing with /dashboard. Okay, in the next scrim, let's work out how to sign up and add a user into the Auth.Users table from our sign up component. See you then. Users can sign in, sign out, but not yet sign up. So let's fix that. Remember a few scrims ago, we had to manually add a user on supabase.com to our Auth.Users table. Well, we now want users to be able to use our form in the sign up component. Here it is. It will add them to the Auth.Users table, and remember, also sign them in at the same time, meaning that Supabase will issue them the JWT, the client library will create that session object, and they'll be navigated to /dashboard. We already have the front-end code for the sign-up component, and we're going to see a lot of similarities in the auth and form submit functions since the logic is essentially the same. Okay, I'm going to write the auth function, and then I'm going to get you to help me finish the sign-up component. So here we've got sign-in user, and we've got sign-out, and below here, let's write sign-up. Since it's essentially the same logic, I'm going to be a little bit lazy and copy the sign-in user function. And now we're going to call it sign up new user. Okay, so we need to change this method here, and it's simply called sign up. Do have a look in the Supabase docs for this method. The user provides their email and password, so this is all going to be the same. We can change this to sign up, Supabase sign up success. And then it'll be unexpected error during sign up. And this can stay the same. Okay, that was pretty easy. Now we don't need to forget to add it to our context value object so that we can access it in signup.jsx. There we go. Okay, so when I wrote the sign in form handling, I challenged you to set up the use action state and extract the form data. And I wrote calling the auth function and error handling. Let's swap roles this time. So I'm going to start off helping you a little bit by importing our use auth hook. And then we're going to extract the sign up new user function from this hook. And I'll set up the use action state and then you'll finish it off. So let's import it at the top. And then we say use action state. And we destructure error. Submit action, and it is pending. And then here we're going to pass in our async arrow function, and then initial value of our error state is going to be null. And then in here, remember, it's the previous state and the form data. And I'll do some extracting of the values. So we've got email, and we use the form data.get. And this one's going to be password. There we go. Okay, that's a decent amount of help for you. And before I set you loose, let's add this to the forms action prop. Okie dokie, challenge time. So I've put it in here because this is where we need to be coding. You can do it below here. This might look a little bit daunting, but remember, you can always reference if you need some help the sign-in.jsx because it's going to be essentially the same. So I'd like to call sign up new user, passing in the email and password parameters. Destructure the response into 3 parts. Now, if you need some help with that, it's absolutely fine to look in here and see what we're returning here. So remember, we've got success, we've got error, and we've got data. Handle errors by returning the error. So that's one of those destructured parts here, using the error constructor. Handle success, checking 2 parts of the response. Have a think what that means. By navigating to /dashboard and appropriately returning. And then 4, handle any other cases as a final fallback. So remember, we've talked about a use action state. This function here must return something to update the error state. So it's really good practice to have a return at the end of the logic as a final fallback. So potentially the sign-up request to Supabase could succeed, i.e. there's no errors, but the response data doesn't contain a session object for some reason. There could be a delay. It's always good to have this fallback, okay? All right, take it slow. Don't be scared to reference this if you need a little bit of help. See you in a minute. Okay, brilliant. One step at a time. So we call sign up new user and we pass in the email and password like that. We destructure the response. So we've got success boolean, we've got data, and we've got error. And this time let's call the error sign up error. And we need to not forget that await word because it's async. Okay, number 1 done. Number 2, handle errors. And we're calling the error sign up error. So we say if sign up error by returning the error using the error constructor. So we return and we go for new error and we just pass the sign up error. There we go. Number 2 done. Number 3, handle success. So we know that success is a boolean, so we can just say if success, but we've been reminded to check 2 parts of the response. So we haven't checked data yet. And remember, the true check whether this has worked is whether we have data back from Supabase. So we're going to also check with the double ampersand the data, but it's what in the data that's really important that shows that we've signed up and also signed in. Well, sign in is all about whether we have that session. And we saw the response back from sign in. The data object we get back has a session property. And then we remember to be really careful with this data. We're going to add the optional chaining operator here, just in case we try and access this before it's gone back and to mitigate any runtime errors. So if there's success, what do we want to do? Navigating to /dashboard and not forgetting to appropriately return. So we need to return something. Remember, we're updating the error. Well, it's starting at null and there's no error, so we don't want to change it from null. So let's just return null. Let's finish off this navigate part. So we need to import the use navigate. And then we need the navigate function. There we go. And then we can simply use navigate and pass in the path we want to go to. Okay, lovely. That's number 3. Number 4, handle any other cases as a final fallback. So final means it needs to be the last thing after all of these ifs. And just so we definitely return something, let's just return null. Okay, all of that's done. Tidy this up. There we go. So we deal with any error back from Supabase, or actually any unexpected error as well, because remember, unexpected errors, we're also returning an error here. Great. And we're being really careful on checking whether we have the session in the data back from Supabase and that we've returned that success as true. And we've got our fallback. Okay, save that. And now, just like we did in sign in, I can use this error down in the return to create an error message. Let me type this out quickly as it's the same as before. There we go. And then let's work on all of the accessibility we need. We can copy this down here. And then let's just use isPending here to conditionally render the button. Okay, there we go. Let me see if I can sign up a new user. It's going to be Jim this time. Fantastic. No error, and we see Jim's email address in the header. And when I check my Auth.Users table in my project on Supabase, I see Jim there. I'd like you to pause the video now and try signing up a user into your project. Once you've done that, I want you to check your Auth.Users table and make sure the new user is there. Okay, fantastic. We can log in, we can log out, we can sign up. We're really getting there. But I think it's time for a refactor. See you in the next scrim where we'll discuss why. Now we move on to adding an account type for each user. To start with, let's only sign up sales reps, those making the deals, and admins. Eventually, we are going to limit reps to only be able to add deals for themselves, whereas admins can add them for any other reps. Before we implement users being able to sign up and include either an admin or rep account type, let's talk through an action plan. When we sign up a new user, we need to store which account type they are somewhere. we can include extra data on signup in a part of the Auth.Users table called user metadata. Let me show you. If you could navigate to your authentication page, so if you go to your project dashboard here, it's, remember, the fifth icon, the thumb up on the left. Authentication looks like this. We immediately get taken to the Auth.Users table. And then I'd like you to click on one of your users, and then you see some of the data from the columns here. But I'd like us to go for raw JSON. In the Supabase web UI, when you look at the Auth.Users table, you typically see a set of standard columns. Some columns, especially those with complex or JSON data types, are not shown by default. That's why we need to go into this inner menu. Then we have that unique UID here that's also shown over here. We have the role, you see, because they are a signed up member, they're authenticated, the email they use to sign up with. If you scroll down, you should see a part called raw user metadata. It's already got their email. This is just an example I made. I know it doesn't correspond to Dwight, but this is just an example, okay? Now, this is where we can actually store more extra fields, such as potentially account type. The sub here is subject. It's actually just the same user UID that we saw earlier. I know it's not the same because this is just a different example, but they would be all the same for the same user, okay? When the JWT is created, this data is included in the user metadata claim of the JWT. Remember, the claims are in the middle payload part. So we can actually base RLS on it. Let me give you an example of a potential policy that uses this user metadata part of the claim. We're using another one of those Supabase helper functions here. Earlier we saw auth.uid and we saw auth.role. But here is auth.jwt, so this returns the whole JWT. And then we use this single arrow to access JSON, which this user metadata part is in. And then the double arrows means that we're looking for the string value from the account type property. So it's saying the string value of the account type property needs to equal the string admin. So this is a little example policy. I've called it only admins can delete deals. So I've made it only authenticated users. And I've said the person making the request, because it will be from their JWT that they send with that letter, the user metadata part of the JSON part, the string value of the account type property has to equal admin. Basically meaning the user is an admin. So this would be if we've added this account type part into the user metadata claim of the JWT, we could base an RLS policy on it like this. But the raw user metadata can be updated by an authenticated user using another of the Supabase functions. It's actually called auth.update. This would mean there could be a malicious attempt to self-upgrade. So somebody could sign up as one account type, and then they could use this auth.update function to upgrade to an account type that has more privileges. So this user metadata is not a good place to store authentication data like account type if we plan to base RLS policies on it. Remember, we can base RLS policies on it because it's included in the JWT with each request. Now, in our app example, I do realize it's a little strange to be hung up about this, since we're going to be letting the user on sign up choose which account type they are. In a real company, you can imagine that a new employee wouldn't be able to choose this on sign up. Somebody, say, in tech support would create an account for them with their correct account type association. So our first problem now is, where are we going to store the account type? Since it's not secure to store it in our user metadata part of the JWT if we plan to base RLS policies on it. On to problem 2. So we want to limit reps to only adding deals for themselves. You can imagine why we might want to do this. And we're going to go about this in 2 ways. The first way is the UX. So our new deal, add a deal form, we can make that name field be their name, not a drop down like we have currently. We could also make it read only so they can't change it. So they're forced to only be able to add a deal for themselves. We can also limit it using RLS, our sort of last line of defense. we can say the name in the inserted deal row has to match. Here's our problem. So this is what it would look like. The RLS bouncer can be told only allow authenticated reps to insert their rows, so rows with their own name, into sales deals table. Now the problem here is where do we have name of the user? We don't have name in our Auth.Users table. The only place name is really is on the JWT in the start of the email, but we don't really want to be writing a policy that checks the start of somebody's email. RLS, remember, can only check the JWT, info about potentially what is being inserted if it's an insert request, and it can reference data in the database. So where is name? So we hit a bit of a wall thanks to the way we have our sales deals table currently set up. Right now it looks like this, doesn't it? The way we know the owner of each deal row is using this name column. So a potential RLS policy would say, allow insert if the name column of the inserted row is the same as, again, we struggle. What in the JWT? I guess we could add a name part to that user metadata claim on sign up. Oh, but we said it's not secure to base RLS policies on that because it can be self-upgraded. And as we've said, we don't really want to base it on the beginning of the email before the @ symbol. You see, we have now a second problem. So these are our two problems. Where are we going to store the account type on sign up of each user? Since it's not secure to store it in the JWT's user metadata if we're going to base RLS policies on it. And then this sales deals table row ownership issue. Currently, we take the ownership of each row thanks to the name column. But what are we going to reference that name to check that reps can only add rows of their own name? Luckily, with some refactoring, we can solve both of these in a secure way. In the next Scrim, you're going to find out how. See you then. Here are the two problems we talked about in the last Scrim. Where are we going to store the account type for each user when they sign up? We want two to start with, rep, sales rep, and admin. It's not secure to store it in the JWT's user metadata part if we're going to base RLS policies on it. And then number two, we've got this sales deals row ownership issue. Let me talk a little bit more about that now. In general, setting a text field as the ownership of a row is not great practice. Since it's only a text field, any text could be added. Since it's from the user, it's not made by the database. There could be typos, it's just not secure. Since we now have signed up users who each have that unique UID, which is created by the database, here it is for Dwight, there it is. So that was created by the database when I signed him up. And it's these users, or the rep ones anyway, when we can associate them with an account type, who are making the deals in sales deals table. It would be a much better idea to replace the name column. Here's our sales deals table. So we'd replace this name column with a user ID column, which corresponds to that UID from the Auth.Users table. Then the ownership of each row in this table would be down to the UID that the database created. Much more secure, not just a string. But then where would we store name? We do need the name for each deal somewhere so that we can populate our bar chart. The default Auth.Users table is managed by Supabase and contains only basic fields. And we've already talked about why we can't store name in user metadata if we're going to base RLS policies on it. So it's actually better practice to have a separate table. Let's call it user profiles here in the middle, in addition to the default Auth.Users table provided by Supabase. A separate table lets you store custom fields like account type. You could have like an avatar URL, preferences, teams. Much better for scalability. You can easily populate this when a new user signs up. We'll talk about this in a minute. And then we can easily join our business tables like sales deals with this user profiles table and join it on the ID. So you see this line connecting it. FK stands for foreign key here. So user ID in the sales deals would be a foreign key to ID in user profiles, which in turn would be a foreign key to the ID in users. Here's this ID that we saw in the table called UID, created by Supabase when a user signs up. And this format would make it easy to display user information in dashboards like our chart. The ownership of each row in sales deals is based on the user ID. And then if we want to know the name of each row, we just do a join to the user profiles table. And the important thing here is we can secure this with RLS. This user profiles table can't be updated by the user. Remember, we said if we based RLS on part of the user metadata, this can be updated by the user. We could then pretty much easily limit reps to only adding deals for their own IDs. Because when they try and add a deal into sales deals, we can say check the user ID of the JWT, so who's making the request, check it in this table. Does that ID in user profiles table have an account type of rep? If it does, make sure the ID of the deal they're trying to add is equal to the ID from the JWT, i.e. who's doing the adding. And then for admins, if we want them to be able to add a deal for any of the reps, what we can do is we can fetch a list of all these user profiles, their ID and name, and then when the admin selects a name, we can say get the ID of that name and insert a row into sales deals with that ID. And you can see here, this new format, we've removed the name column from sales deals. So if we're going to go for something like this, we need to work on how to get the name and account type into this user profiles table. We have two options. We can either write an insert request straight after sign up. This is pretty simple, but it would require two operations, right? A sign up function and then an insert request. Our other option is to use a Supabase trigger, which happens immediately after sign up. This is an automatic part of Supabase. We wouldn't have to make it happen in the application level, but it is a little bit more complex. We'd have to learn how to write Supabase triggers. So the trigger takes the new record from the Auth.Users table and inserts it into the user profiles table. It wouldn't be two operations. It would just be the one sign up and then the trigger would automatically fire. This approach is more consistent with the Supabase design patterns and best practices, and it does create nice separation of concerns. But you might be thinking, well, Jonathan, if we wanted to trigger it from users to user profiles, we don't have name and account type in the users right now. Well, I mentioned the user metadata part of the users table earlier. I stress it's not a good idea to store auth data that we base RLS on. But what if we don't base RLS on it, but use it as a sort of parcel to take data from the app, the sign-up form, into Auth.Users, and then let the trigger populate user profiles, and then base the RLS on this table? This sounds like a good plan. Of our two choices, I think I'm going to make the decision of going for the trigger. It may be more complex, but we do have an opportunity to learn more about Supabase. So we're going to use this user metadata part as a sort of temporary transport way to get the extra data, the name and account type, into this database table at the moment of user creation. As long as we don't base any RLS policies on the user metadata part of Auth.Users, we're going to be okay. We're going to copy, using the trigger, the relevant data into the user profiles table where we control access and integrity. So even if somebody could change and tamper with their user metadata part, it's not going to affect the app's security or permissions. So I know this looks like a lot, but let me go through it slowly. The user's going to sign up. They're going to include their name and choose their account type. The user is added to Auth.Users, that's automatic. And then the trigger we write is going to transfer the name and account type and the ID into user profiles. Because signing up also signs them in, Supabase will send the JWT to the client, which will create the session object. We are then going to fetch all of the users from that user profiles table in our application. If the user is a rep, we're going to find the current user from the users table using their ID. We're then going to set form input value as the name of that current user. This is the UX limitation we said on the new deal form. They would only need to choose a value because the name part would be read-only. If they do choose a value, we would find the user ID of that submitted name from the users that we fetched here. We then insert that deal, the user ID this time, not name, and value into sales deals, and our real-time subscription would fetch the new data from sales deals, aggregate it, be joined with user profiles, so that's where we get the name part, and then we visualize it on the table. If the user is an admin, we still can populate the drop-down, the new deal drop-down from all of the users that we've fetched here. They can choose a name of only the reps and a value, and we do the same to populate the sales deals table. Do pause on here if you need to go through that again yourself. We'll be referencing this as we go about refactoring, so don't worry. So to make that happen, here is our Refactor to-do list. We need to create this new user profiles table and appropriate RLS. We need to update our sign up component so that it includes name and account type. We need to write our trigger. We need to update the sales deals table and new RLS. We need to fetch all of the user profiles, and we need to update the form component, and then update the fetch metrics function, which will populate our bar chart. Lots to do. Let's get on it. See you in the next scrim. Our first job in the big Refactor to-do list is to create a new user profiles table. This is going to be in the public schema. So the green here represents public schema and the orange is in the auth schema. I'd like you to follow along with me so we do it together. I'll do it in my project and you create it in your project. So I'd like you to navigate to your table editor. That's the icon below the home on the left on supabase.com. And on the far left, it will say schema public and new table. We're calling it user_profiles, just like that in the middle. We keep enable RLS turned on. And then we look at the column. So the ID and created at are already populated there. We need to add a name column with type text and an account_type column, also type text. And let's put the default value as rep, which will be the account type with the lowest permissions. So pause and add those now, please. Then if you scroll down, we're looking for add foreign key relationship. Remember in this slide, we said the ID column in user profiles has to be a foreign key to the ID from users. So I'd like you to select the auth schema and the users table. I think it's right at the bottom of the dropdown. And here it says select columns from Auth.Users to reference to. So on the left, it's the column in user profiles, which will reference to this column in Auth.Users. And we can see here, it's the IDs of both. And then scroll down and save at the bottom. So we're referencing the Auth.Users table to ensure data integrity. We don't want a row to be inserted in user profiles if there's not a corresponding user with the same ID in users. Every profile must belong to a real user in users. So when a user signs up, the trigger we're going to write later will add their ID, name and account, which will be in user metadata, into the user profiles table. So thinking about RLS policies, do we need to write an insert RLS policy allowing this trigger to happen? Well, if we think about how the data is getting into user profiles, it's via this trigger. We're not actually writing an insert request in our application. And when we write the trigger, we're going to be creating it with the term security definer. This means it runs with the privileges of the function's owner, i.e. us. We're going to write the function, and we have elevated privileges because we're the database owner. It doesn't run with the privileges of the caller, the person who is signing up, who made the trigger happen. So because we have these elevated privileges as the function's owner, if we had written RLS, the trigger would have bypassed the RLS anyway. So that means we don't need to write an insert RLS policy for user profiles table. But if we think ahead and we look back at this slide, how are we getting the name and account type so that we can use it in our app? Well, remember this block here. We're going to have to fetch all of the profiles in our app to be able to verify account types and use the names in the chart. So since this block is from user profiles, we need to write an RLS policy that will allow the data to be fetched or selected from user profiles. So let's do that now. If you could navigate to your authentication part, that's the thumb up. Remember, the fifth icon down will look like this. And then click policies just below configuration. And then you should see both tables now, the sales deals and the user profiles table. Since this policy needs to be on the user profiles table, click user profiles and then click create policy. It should look like this. It will automatically populate this table dropdown. Now, the policy we need is basically going to say authenticated users can view, select all of the profiles, all of the data from this table. Let's use this opportunity to learn about the target roles to clause. Remember that the supabase role is either authenticated or anon. We saw it in the JWT. Well, we can use this drop down to select authenticated and not actually need to use the supabase helper function that we did in the past, that auth.role. In the past, we said auth.role equals authenticated. But this to clause will actually do that for us. It will actually add a to clause here. You could try that actually. If you select the drop down and go all the way to authenticated, you'll see that it adds a to clause. Now, if we're not putting anything in the using clause, because we don't need the auth.role equals, that's going to cause a problem because every policy needs something in the using clause. Since the using clause is the core of RLS, it's where we define the logic for which rows a user can access. The way we can get around this is using the word true. It's a condition that always evaluates to true for every row. It means the policy will allow the action for all rows. It's kind of like saying no restrictions. So this is the policy I need you to add. We're going to call it users can view all profiles. You're not going to have to touch the on because that's already populated. Permissive is by default. It starts on select, so you can leave that. There's that to clause that's been created because I used the target roles dropdown. And then I'm just writing the word true there. So that means as long as they're authenticated, all users can select from user profiles. So pause, finish this off, and then click Save Policy. Now we have the new table set up with an RLS policy. Now it's time to modify the sign up component to add account type radio buttons and a name field. See you in the next scrim. Okay, we've set up the user profiles table and any appropriate RLS. Now we are on to updating the sign up component and the sign up new user function. I've been so bold as to add 2 radio buttons here for select your role. Now remember I said we're going to start with just admin and sales reps. Now the word role here is job role. Let's not get confused with the supabase role of either admin or authenticated. So the only place we're going to use the word role is on the UI here. If we scroll down to the field set, you can see that I'm actually calling this input the name of account type. We're going to reference that from now on as an account type. We also need a name input. So let me copy the email one here, change it to name. This is going to be name. It's going to have a type of text. It's going to be the name of name, ID of name, and then I think this can all stay the same. Okay, let's save that. And we now see we've got a name field. Great, so challenge time. I know it's been a while, quite a short one. I'd like to extract the name and account type from the form into variables. So we already have email and password. You can continue below and then pass these extracted values as additional arguments to the sign up new user function just on here. All right, good luck. I hope that went well. So I'm going to copy this line and just make 2 more. And then we need a name variable and we need a, let's call it account type like that. And then these are going to have to change. Obviously, name we called name and account type I mentioned is going to be account-type. There we go. And then we just pass these values as additional arguments. There we go. Brilliant. So we delete the challenge text. So let's have a look at our sign up new user function in auth context. Here it is. We only currently have email and password, so let's change that now. There we go. So when we talked about our plan, we said we were going to put the name and account type in user metadata as our sort of parcel, and then the trigger will populate user profiles. So we now need to add name and account type into the user metadata part of the users table. Let me show you how we're going to do that. So we don't just pass it to .signup like this. We add an options property. This is an object which has a data property. It's like Inception. And then whatever we want to add to the user metadata, we put in here. So we want a name property with the name from up here. And we want an account type property, which is that account type from there, and it changes color. There we go. So this is how we add to the user metadata part of Auth.Users. Okay, another thing ticked off from our Refactor to-do list. Next up, the trigger. See you in the next scrim. It's time to write our supabase trigger, which will pass the data from the Auth.Users table when it's inserted there into our new user profiles table. Now, a bit of a pre-warning, there is going to be some PostgreSQL syntax coming up, and it's fine if you don't understand it all at a deep level. Do have a look at the Supabase docs on trigger, and you'll find an example one there. So I've made a little trigger.sql file here, so we can write it all in here. Then I'll give you a little challenge to rewrite out some of it so you get a little bit of experience there. And then I'll ask you to actually import it all into your Supabase project SQL editor and run it to set it up. Creating triggers involves two parts: a function, which will be executed, called the trigger function, and then the actual trigger object with parameters around when the trigger should run. So we start with the function. I'm going to write out the boilerplate code, and then we'll talk about what each thing means, okay? Okay, so we start by creating the function and naming it. Functions are also on schemas, a bit like tables, and the default schema is always public in Supabase. So we're just going to be explicit and say public dot, and then we can name it whatever we want. Why don't we go for handle new user? And because it's a function, we need the smooth brackets. Okay, that line is done. It always needs to return a trigger. Because this is a special type of function, these must return a special type called a trigger. So we just write returns trigger. Now the language we use, this is Postgres' procedural language, and that's PLPGSQL. Now here's that security definer we talked about in a previous scrim. If we write security definer in the function, then it runs with the privilege of the function's creator, i.e. us, the database owner, not the person who calls it, the person who's signing up and causing the trigger to happen. So remember, this security definer means we don't need to write the RLS policy allowing the trigger to insert into our user profiles table due to the elevated privileges that this gives us. Oh, I meant to write set here, but it's changed it to security. There we go. So if we want to prevent search path injection attacks, then we write set search underscore path equals and an empty string. Now these $ marks the start and end of the function body. Okay, so in here we use begin, and then funnily enough, right down here we're going to say end. So we think, what do we want to happen when this function runs? Well, we want to insert into our user profiles table. So we say insert into, and user profiles is in the public schema, user underscore profiles, and then we write the column. So let's just put a little comment like that. And then we use values and smooth brackets to specify the values for those columns. And then below here we return. And we need to return a trigger variable. And this is a special record that represents the row that was just inserted or updated, which caused the trigger to fire. And we reference that row with the word new. So when a row is inserted into users on sign up, the trigger will fire. And the row that was inserted into users is now called new. And we reference that data with the new dot whatever it is. Okay? So let's write a little comment here. There we go. Brilliant. So let's start by going through the columns that we want to insert. So let's have another look here. we want ID, name, and then account type. And then these values are going to be the values of those comments. And we must stick to this order, ID, name, account type. So why don't I write some comments? ID, name. So the first thing in value must be the first thing here, okay? So we want the value of the row that caused the trigger to fire. And we know that we reference that with the word new. So this will be new dot and then whichever column. Now we're looking for the ID from users. So it's going to be new.id. There we go. And these are all going to be new dot something because they're all coming from the row that caused the trigger to fire when it was inserted into Auth.Users. Now name and account type, they remember are in user metadata, and that's JSON. So we have to use something a little bit different here. We're going to say the row in Auth.Users is actually called raw user metadata. And because it's JSON data, we have to use a special operator, which we have seen before in a previous scrim. It's this double arrow. This extracts the value as text from JSON. So new.raw user metadata is the JSON column. So the double arrow extracts the value as text from the name property in this column. And then it'll be very similar for account type. There we go. So the ID column will be populated by the new row's ID. The name column of user profiles will be populated by the new row's value of the name property of raw user metadata, and so on. Okay, trigger function complete. So we've said what happens. We want to insert into this table. Into where? Well, into this table with data from the row that has caused the trigger to fire and these columns from it. Onto the trigger object. This is when should this trigger function happen. So in a similar way, we just say create, and this time not a function, but a trigger. And we call it something, let's go for on auth user created. We don't need to specify the schema this time, as by default, it belongs to the same schema as the target table. There are two types of trigger, a before and an after. The before, these triggers can modify the data before it's inserted or updated. And then after is after it is. So that's what we're looking for here, after it's inserted into Auth.Users. So I say after, and after what? Well, an insert on which table? The Auth.Users. And since we want the trigger to execute once for each row that is inserted, we say for each row. And what do we want this trigger object to do? We want it to execute the trigger function that we wrote up here. So we write procedure, and then we put the name of the trigger function, which we called public.handle new user. There's the trigger object, okay? So this is saying when should this function run? After an insert on Auth.Users, and it's going to happen for each row. Remember, if you don't understand all of the syntax, don't worry at all. So triggers are automatic. No need to manually create these profiles from our application. It's secure, it runs with elevated privileges, but in a controlled way. And it's maintainable because the profile creation logic is centralized in the database. Okay, I promised you a challenge. I have removed a few parts and I'd like you to complete them. So I'd like you to name the function on the public schema. I'd like you to complete the table name, where are we inserting into, and then in brackets the columns. Let me just help you with those brackets. And then I'd like you to complete the account type JSON extraction. I've been very helpful and left the other one here for you. And then in the object, I'd like you to name the trigger. I'd like you to complete the table after inserting on. So think about the logic there. And then complete the function name and schema that you have put up here. Great. Good luck. See you in a minute. Okay, I hope that went well. So we called it public.handle new user. This is all good. And then we need the table name. So we're inserting into the user profiles. And that's on the public schema. And then in the brackets, we have the columns. So they represent these columns. So we've got ID, name, and account underscore type. and then complete the JSON. Yes, so we can actually copy this, can't we? Just for speed. And this would be account type. And then that's all finished. And then we come down here, we name the trigger. So this can be anything you want. We went for on auth user created after inserting on, well, auth.users. If you need to see that again, just for clarification, after the signup has added the details into users, we want the trigger to fire and add into user profiles. For each row, yeah, and then we can just copy the trigger function name we put up here down here because it executes that procedure. Okay, fantastic. Let me get rid of these comments. There we go, that's fixed. Thanks, autocorrect. Okay, so we need to now run this in our project. So you need to go back to your project dashboard. We're now looking for the SQL editor. So this is the third icon on the left. Should look like this. I'd like you to pause the video, copy all of this, paste it in here at the top, and then click Run. Okay, do that now, please. Okay, now we need to delete everybody in Auth.Users, because remember, we don't want anybody in Auth.Users who's not in user profile. So we need to sort of start again. Okay, so I'd like you to navigate to your authentication part. That's the thumb up. Click everybody you have in Auth.Users. You can either right click and delete, or you can click the little square and then click delete. And once you've done that, I'd like you to test our application by signing up somebody as an admin. I'm going to sign up Pam as an admin, and then Dwight again as a rep. And I'm going to check my Auth.Users table to see that they're in there. And I can check the metadata by clicking on them and going into the raw JSON and looking for the metadata part. And I'm going to check my public.user profiles table. You can do this via the table editor. Okay, I'm going to do that now. So here we go. So I'm going to go for Pam. She's going to be an admin. Great. I can see a session created in the console. And if I look in my Supabase project, I can see Pam in Auth.Users and in user profiles. And she has an account type of admin. And I do the same for Dwight. And he's a sales rep. And there we go. Brilliant. Now that reps and admins can sign up and their name and account type are being stored in our new user profiles table, it's time to update our sales deals table. See you in the next scrim. On to refactoring our sales deals table. Rather than identify the owner of each deal in sales deals by the name column, which we've been used to, we need a user ID column. So follow along with me now. In your Supabase project, please navigate to the table editor. That's the second icon down on the left. Click your sales deals table, click the green insert and choose insert column. We're going to call our new column user_ID. It's going to have type UUID. Then scroll down and we need to add a foreign key relationship. Remember, this user ID will be a foreign key to the ID in user profiles. So choose public schema, choose the user profiles table, and then again it says which column in public.sales deals, and that's the user ID column, this new column we're adding at the moment, is going to be a foreign key to the ID column you need to choose in user profiles. Then click Save. You might want to delete the name column, but we're going to leave it for now. We're going to delete it when we modify our fetch metrics function. So let's think about RLS then. Currently, we've got this very broad authenticated users can do anything on sales deals. This is that first policy we wrote. Our goal is to limit reps to only being able to add deals for themselves, whereas admins can insert for anybody. So since we want to add more restrictive policies regarding inserting data, we're going to have to replace this policy here, our original one, so that it's just for select commands. You might be thinking, why don't we just leave it? Well, this broad policy, if we did leave it, would take precedence over more restrictive policies we write, as Supabase policies are additive. You can kind of imagine them as combined with an OR, which means that the most permissive policy takes precedence. If we left it, we'd have this policy saying authenticated users can do anything, and then we'd think of it like, or our new restrictive policy that reps can only add deals for themselves. But because there's an or, this broad one would catch all of the scenarios, making the more restrictive one essentially redundant. So we're going to have to replace that one with one that looks like this, which is just for selects, leaving us to now write new policies for insert on this table. So this is what we're looking for now, a new policy that says allow select from sales deals to authenticated roles, replacing the previous one that said allow any request. So this is your task now, okay? I'd like you to go and delete the previous policy on sales deals, the one which was called authenticated users only here. And I'd like you to write a new one that's just for select. And I'd like you to try using the target roles clause. Remember, this means that we don't need to bother with the using auth.role equals authenticated. We can just choose authenticated in the target roles, which will create a to clause here. And think back to what we had to put in the using clause if we use the target roles, because something has to be in that using clause. Otherwise, Supabase won't let you save the policy. So pause the video now and go and delete the old authenticated users only policy and write it again, but only for selects, and use that to authenticated via the target roles dropdown. And when it says you need something in the using clause, go for the word true. I was going to get you to try and remember it, but I'm just too nice. Now, before you save your policy, continue the video to check your work, and I'll show you here what it should look like. Pause now. Okay, I hope that went well. So it's supposed to look like this. I've called mine authenticated users can fetch. I've chosen just for selects. I've used the to authenticated and the word true in the using clause. Okay, now you can save yours. And now that select is dealt with, let's deal with the new insert commands. See you in the next scrim. Now that we've replaced our original broad policy with this select policy here, we're now on to dealing with insert policies. The two policies we're going to need to write are for reps to only be able to add their own deals and for admins to be allowed to add deals for anybody. When we learned about RLS, I said we can combine checking the JWT with other database queries. And of course, the data being sent if there's an insert policy. Well, now we need to check if the inserted deal ID is the same as in the JWT, i.e. who's making the request, and that there's a row in user profiles with this UID, and that row has an account type of rep. It's a little bit to get your head around. Hopefully this will help. So the bouncer in front of the sales deals table, they have been given these two orders. The first one down here is allow authenticated reps to insert their own deals into sales deals. So the fact that they're reps, that needs to be worked out. And then another thing needs to be worked out is that the deal they're inserting has the ID which corresponds to their ID, right? It's kind of like two checks which needs to be made for that policy. And then they've also been told for admins, allow authenticated admins to insert anyone's deals into sales deals. So here they only need to check that the person doing the inserting is an admin, because it's a bit broader, isn't it? Anyone's deals. So if we have a quick look back at this, the way that we're going to check if the person doing the inserting are an admin or a rep, well, that's here because the account type is crucial there. So we need to say the person doing the inserting, their ID, we can get that from the JWT, and then we can look in user profiles for that ID and see what the account type is for that row. And then for reps, to make sure they can only add their own deals, we can take the ID from the JWT and check the row they're trying to insert into sales deals, the ID of that row. So now I'm going to show you how we do the check to find out if the person doing the inserting is an admin or a rep. So the way we check if a row exists in a table, because that's what we need to do, don't we? We need to check, does a row exist in user profiles, which has the ID of the person doing the inserting, and the account type of that row is either admin or rep. So the way we're going to check this is we're going to use the word exists, and then we start a bracket, and then we sort of start a new SQL query. So we say select, and we're going to use the one. I'll explain this in a second. And my little example here is, let's imagine we have a table called extended family. And I want to check if a row exists in this table. And I want to check two things. Whether the shoe size column is 10, so that would be extended family dot shoe size equals 10. And my second thing I want to check is whether the favorite color column is red. So if a row exists in extended family where both of those things are true, then this will return true. So I'm going to leave that there to help us. So the two policies we need a policy for reps to only add their own deals. And then the other one was admins to add anyone's deals. I'm going to write this first one, and then I'm going to set you a challenge to write the second one. So let me type out the boilerplate. So let me just call our policy that. It's going to be on sales deals. And it's for inserts, isn't it? We've done the select in the past, but now we're working on inserts. Must be authenticated user. Now, the with check. Do you remember I mentioned we need two checks? So the first check is ID on JWT is the ID of the inserted row. And then the second check is, does row exist in user profiles with ID from JWT and rep account type, yeah? So this one. So how do we get the ID from the JWT? We can use one of those fancy supabase helper functions. It's Auth.UID. So that has to be the ID of the inserted row. Now, when we're inserting a new row, Postgres allows us to reference the values that are being inserted in the with check clause. So we actually simply just use the column name of the inserted row, and the column name is user ID. So in the with check, Postgres lets us directly reference a column of the inserted row. So now we need an and exists, because we're about to start this how to check if a row exists. All right. So we know how to do this. We could even copy this and paste it in, right? So we use our select one. Oh, I actually failed to tell you about select one. So this is a simple way to check if a row exists. If we selected, say, star, which we're used to in SQL, that would actually return all of the data, right? It would return the data of that row that we're selecting. But we don't actually need the data, do we? We just want to know whether a row exists. We kind of want a true or false Boolean. We just care if there's a match. So 1 is just a constant value that's returned if the condition is true. It's a more efficient way than saying select star, since we don't actually need the data. So that's what we're using here. Select one from, and it's not from extended family, is it? We're looking in user profiles, and it's where the ID from the JWT. So that means the ID column of user profiles equals the ID from the JWT. And we know we can get that from our helper function. There we go. And that the account type is rep. So we go user profiles.account type equals rep. There we go. So this bit is doing this comment here. Does a row exist in user profiles with an ID from the JWT? So that's the ID in user profiles equals the ID from the JWT, and the account type column from user profiles equals rep. So that all basically says the person doing the inserting is a rep. And this part is checking the deal that they're adding is their deal. The ID on it corresponds to their ID. Now, I realize that's a lot. The one you're going to do is actually a little bit simpler, isn't it? So before we get on to the challenge, I'd like you to pause and add this policy to your sales deals table. There's a few ways to get there on supabase.com. You can either go to Table Editor, click Sales Deals, click Auth Policy, and then Create Policy. Or another way you can do it is click Authentication, Policies under Configuration, and then find the Sales Deals table and click Create Policy. And you now know how to get the to clause up, you know how to choose Insert, and you can type this into the with check or copy and paste it. Make sure you don't move on to the next scrim until you've saved this policy. See you in the next scrim where it's your turn. We've written and saved one of our insert policies for the sales deals table. Now it's your turn to write the second one, allowing admins to add anyone's deals. So here's the challenge. I'd like you to write a policy called admins to add anyone's deals. Apply the policy to the sales deals table in the public schema. Restrict the policy to authenticated users only. Check that admins are making the request by checking the current user's UID matches a user's ID in the user profiles table, and that the matching user has an account type of admin. So I'm going to just scroll away. So if you need help, you can always scroll and see how that's done. But the good thing about yours is because admins can add for anyone, you won't actually need this part, but you will need to check if a row exists in user profiles, okay? Good luck, and I'll see you in a minute. Okay, I hope that went well. So we're going to create a policy, and we're calling it admins to add anyone's deals. It's on the public.sales deals table. It's for insert. We're going to use the to authenticated. And now we get onto the with check. So the way we check if a row exists somewhere is we use that exists word. And then in smooth brackets, we kind of start a new select query. We say select one because we are not interested in the data, just whether the row exists. And we say from the correct table. And then the where the current user's UID matches a user's ID in the user profile. So let's do this bit first. The ID in the user profile. So we say user profiles.id equals the current user's UID. So that's the person doing the inserting. So we get that by using our auth.uid. And because we need to check something else, we use the and word. The matching user has an account type. So the matching user will be the same row. So we basically say user profiles again, dot account type equals, and this time admin. Okay, I hope that was all right. I need you to pause the video again and add this second insert policy on sales deals. Okay, brilliant. I hope that's all saved. Do check you have both of these policies set up on the sales deals table. All right, tick 4 things done in our refactor to-do list. Next up, we need to fetch all of the profiles from user profiles so we can use them in our app. See you then. We're making great progress in our big refactor. Now we're on to fetching all of the profiles from user profiles, this block here. Why do we need all these profiles anyway? Well, we're going to be using it quite a lot. We're going to be using them to determine whether the user who's logged in is an admin or a rep. Because remember, account type is in user profiles. It's the only place we can tell whether the user is account type rep or account type admin. So what we'll be able to do is we'll be able to get the ID from the session when they're logged in. Because remember, session is created from the JWT, and that includes their database ID from Auth.Users. We'll be able to take that ID from session and reference it against the ID in user profiles, and we can check the account type associated with that ID from this table. We also need the profiles to populate the drop-down for admins, and here for reps, we're going to be finding the name associated with that ID to set the name input. And then we also find the ID from these users before we insert the deal into sales deals. Now, we're going to need these user profiles then in form, because here we're not going to be mapping around the metrics anymore. we're going to be mapping around these profiles to get the names out to generate the options. But I'm also keen actually in the header to not just render the email of the logged in user, but also their account type. So we're going to need this data in various places. So I think we need to fetch all of these profiles in our central auth context file. Now, if we need to fetch all of the profiles from here, do we have an RLS policy that allows that? Oh yes, we already wrote it, didn't we? It was our users can view all profiles. Good work. It looked like this. It was quite broad. It just said you have to be authenticated to be able to select all of the profiles from user profiles. Okay, so I'm going to start by creating some more state to hold these profiles. Let's call them users. And we want them in an array, so we'll initialize it as an empty array. Now it's challenge time, okay? So we're going to be doing this in useEffect. So why don't I write the challenge text down here so that you can complete it underneath. So I realize this looks quite long, but remember we've got one of our lovely hints here. Follow the same error handling pattern as the fetch metrics function. So let's have a look at that. Because we're selecting data here from sales deals, it's going to be essentially very similar. So you could copy and paste if you wanted, but this time we're going to be writing a fetch users function which queries the user profiles table, getting the ID, name, and account type. Now, remember, back in section 1, we used the supabase translator to write this bit. But actually, I don't think we need to do that now because we're not doing any aggregates for this new function. All we're doing is selecting 3 columns. So all you'll need to do is just write the select and then here just put in inverted commas. Remember, these funny backticks are just because we've got them on separate lines. But you'll just need regular inverted commas. So a little help, it'll just look like select, and then in commas you can just write ID, name, and account type. Okay, you get the idea. I'm so helpful, aren't I? Then we destructure the response into data and error variables. Yes, we're used to that. Using the try-catch syntax. So try this. If error, we throw the error. That's for success. Catch any error, and then console.error. If successful, log the fetch data to the console. Okay, so we can see that array eventually and update the user's state with this data. Okay, using set users. Call the new function below the function definition. So you see here, when we define this function, we had to call it below. You're going to do the same here, below your new fetch users function. Now, a warning, when you save and test by logging in, currently the console should show an empty array. So I don't want you to think that you have done something wrong if it shows this. This is what should display at the moment, okay? As a bit of a stretch goal, I want you to think why this is. Why are we not seeing an array of the data from user profiles? Okay, good luck. I'll see you in a minute. Okay, so I'm feeling a little lazy, so I'm just going to copy this function here. And ours is going to be called fetch users. It's not from sales deals this time, it's from user profiles. I'm actually going to put all of this on a new line and then one line here, like this. And we're selecting, as I said, ID, name, and account type. If error, throw error, that looks good. We're not set metrics, are we? We are going to set users with the data. But before that, we want to console log the data. There we go, set users, and then we're not fetching metrics, we're now fetching users. And then we need to call the new function below the function definition. There we go. Okay, we can clean up this challenge text. I'm going to leave the warning there. So because this scrim's getting quite long, I'm going to move on to the next one. I'll see you there where we can save and we can test and see what's going on and try and work out why this is happening. See you then. Right, time to test this. So I've saved and I look in the console and I see an empty array. Oh, well, that makes sense, doesn't it? Because we've not logged in. And as I said in the past scrim, the RLS policy we wrote only will allow authenticated users to select. So let me log in as Dwight. There we go. And now I check the console again. And I can see that the session has changed. So we now definitely have the session. We're authenticated, but no new console log saying fetched users with the actual data from user profiles. Now, this is why I asked you this question. Have a think why this is. Let's have a look where we wrote this fetch users function. Well, it's in our use effect, and the use effect has got the empty dependencies array. So we think about what we've learned about use effect in the past. That will only run when the component mounts is first created or rendered, not on every re-render. I'm starting to see the problem here. So when we saved, it ran, but we weren't logged in. So that's why we got this empty array here. Then we logged in, the app re-rendered, but a use effect set up like this does not run again, does it? Our on-auth state change radar CCTV picked up the session being created, an updated session here, hence why we see the session change log. And of course, because there's been sign-in success, we see this log, but we do not see a new fetched users log with the data in an array. So to make sure we're right here, if I were to refresh our app, meaning that the entire application is reloaded, a new initial render, fetched users would then run. And we should now, because we're authenticated, see the data back from this .select. Let's try that. So I refresh in the browser. I look in our console, and there we have it, fetched users. And we've got an array of ID, name, account type objects. So there's Pam, and we've got Dwight. So we need fetch users to run after what changes? If you're thinking session, yes, because remember, as soon as session is updated, we know we definitely are authenticated. And that means we can run this, and we will definitely bypass the RLS bouncer and collect or fetch our data. So how in React can we fire an effect when a specific value changes? Now, because of my wording there, I am implying, yes, a use effect. But what has to be different to this use effect that we already have to make the effect run after something changes? If your brain's going to dependencies array, that is correct. If we add something to the dependencies array, then it will run after initial render, but also when that value changes. So it's looking like we need a new use effect with the session state variable in the dependencies array. So let me make that down here. And we're going to move all of this down into the new one. And then we add the session state variable in the dependencies array. Okay, we can get rid of this comment. And remember I said that this new use effect will run after initial render and when session changes. Well, after initial render is a little bit redundant because we already know that it's not going to fetch our data because we won't be authenticated. So why don't we set a little if statement here to check and return if there's no session. So we say if there's no session, just return there and don't continue down the effect. So that will mean that this doesn't run on initial render, but because we've got session in the dependencies array, it will run again when the session object is full of data, meaning it will bypass this, run this, and we'll get our juicy data. Okay, last thing to do, we need to do something with this because you see how it's grey? That means we're not using this user's state array. We need to add it down here to our context, yes, so that we can access it through our app. There we go, and it's changed color. Beautiful. So let's save that. Now, let's test again. We now don't see the empty array on initial render, thanks to this line. I log in again. We check the console, and there we have fetched users. So thanks to this session in the dependencies array, because session has updated with the session object after login, this runs and updates our users. Brilliant. Another tick. Next up, updating the form component. See you in the next scrim. Now it's time to update the new deal form. Before we start this scrim, I just wanted to make a quick comment about this sales deals form. I realize I did not talk about why we have an ID column as well as a user ID column. I just wanted to make sure this is really clear. So we used to have name here, but now we've replaced it with the user ID column. If you remember, every time we've created a new table, Supabase has auto-created an ID column. This is the primary key. This is a unique ID for each row in this table. This was created back when we created the sales deals table in section 1. And we aren't actually ever using this ID. I realize I may have actually referred to the user ID now that we've got that just as ID, because as you can see, it can be quite easy to get confused between ID and user ID. So I'm just taking a moment here. Whenever I've referred to ID, when I should have said user ID, about the sales deals table, it's always about this foreign key. Because it's this user ID here, which is telling us who owns each deal, each row in the sales deals table. It's this user ID, which is the foreign key to the ID in user profiles, which, as I've said, is in turn a foreign key to the ID that Supabase gives every user when they sign up. That's sort of our link between our tables, as you can see here. I hope that makes sense. Sorry for any confusion in my wording. Right, onwards. So now that we have all of our users from the user profiles table fetched, we can now populate the form dropdown with the name from this users array. We'll eventually be only doing this for admins, but that comes a bit later. And we also need to find the current user's name so that we can set the form input value as this name. And that's for reps. So in form, it's going to be a challenge time now for you. And I'm going to put it down here because you're going to be modifying generate options. So I'd like you to access the fetched user profiles through context. So you're going to have to import something up here, and you're going to have to destructure something here. Hint, hint. Then I'd like you to refactor the generate options function to map through the users array. That's the one you're accessing through context in step number 1. So it's not going to be metrics.map, it's going to be users.map. And you're going to have to think about what you're going to set the key prop as for this option. Key has to be a unique identifier. So if you want to think about what you're going to have in these users array, if we look back at auth context where we selected from user profiles, you're going to have ID, name, and account type columns. So they will be properties in an object, which is in the array. We saw that in the console earlier. And actually, that's the hint here about what you're going to set the key prop as. And then I'd like you to save and test by logging in to our app and using the form dropdown. You should see all of the names of the profiles that you have in your user profiles table. If you want to add more, you just need to sign up different users, which the trigger will populate the user profiles table. Okay, good luck. See you in a minute. Okay, so context needs our useAuth hook. There we go. And then we'll destructure from the object the users array. There we go. Now the users array is available. And down here, we're going to not metrics.map anymore, but now users.map. We don't want to call each thing metrics. Let's call each thing user. For now, let's just replace all of the metric with user. So we're back in the game. And then we think about this option key. Well, because it needs to be a reliable, unique identifier, I'm going to go for the ID. Remember, we have ID, name, and account type to choose from. And the unique identifier is ID. Remember, the ID references that unique ID that Supabase gives each user on signup. So that is very good. So we're going to go user.id, not .name. The value is the name because that's the same, and then this will be the same as well. Brilliant. So let's save, and I'll log in as Dwight. And I can still see our drop down, and it works for me. I don't think you can see at your end, but I can confirm that the drop-down is working. Great. Now, let's have a look up here. In our use action state, we've still got this name, and we're then inserting the new deal object with the name into sales deals. But the new way we're doing it, remember, we've not got name, so we actually need to insert the user ID in the value. So we're going to have to change this a little bit. We need to use the name that's from the form and then search in users and find the ID of that name. And then insert that with the ID and the value. So let's call the submitted name from the form submitted name. So original. And then we're going to get that from the form. So we can just put that there. Then we now need to, let's just put a comment. We need to find the user object from users array, from this array, because remember this is an array of objects of each row from user profiles, that matches submitted name. Because in here, each object is going to have ID, name, and account type. So we find the one that has the same name as submitted name, and let's create a user for that object. So we say user equals, and we need to look in the users array. So we say users, and we're going to use the find method. This takes an arrow function. And for each user in here, let's just call it u. If the name property of that user equals submitted name. If it does, it gets assigned into this user object. Now, our new deal object that we're going to insert into sales deals does not need a name property, does it? We want to insert the user ID and value, not name and value. So let's change this to user ID. And the value of that property is going to be, well, this is the object. And in the object, remember, we've got ID, name, and account type. And it's the ID that we want from that. So we say user, and we access it through the dot syntax. There we go. So we extracted the name from the form. We've looked in our users array and said which object in there has the name of that submitted name and assigned it to this user object. We've then looked in that and found the ID and created a new deal object. Value is going to be the same, isn't it? And that gets inserted into sales deals. So this is using the ID from the found object. And here's the found object. There we go. So if you need to think through that again, just pause it now and go through it line by line. I'm going to make this a little bit better. Okay, super. Let's get rid of these comments. Now, if you look in your sales deals table, you'll see that we've still got old deals in the wrong format, in the name and value format. So I'm going to set you a challenge now to delete those. So I want you to go into your supabase.com project, delete all of the records with the old name and value format in the sales deals table. And then you can add new deals with the new user ID and value format by logging into our app and using the form. You can verify these deals are being saved in the right format via your Supabase project. This will break the fetch metrics function, therefore the chart won't work, hence why you need to verify this via the Supabase project website. Now, this is also an opportunity to test our RLS, since right now, both admin and rep users, when they log in, will be able to choose from the drop-down, from this drop-down. We've not created any UX limitation, so if reps try to add a deal for anyone but themselves, the RLS should stop it. Remember this policy we wrote? Reps can only add their own deals. We said the person doing the adding, their ID has to be the ID of the inserted row. And we said this is the case when they are a rep. So you can actually test. Users with account type rep can only add deals for their own name. You should see an error. If you log in as a rep user and you try and choose to add a deal for someone who's not that user who's logged in, it should fail. But they should be able to add deals for themselves, and admin should be able to add deals for anybody, themselves and other people. Okay, go and do that now. I hope that went well. So I've gone in and deleted all of my old records from sales deals. So let me sign in as Dwight. He's a rep. And I'm going to choose Dwight and go for 3,000. And the form shows something without a name, so we're going to fix that later. I look in the console and there's my new deal. And now if I try to add a deal for somebody who's not Dwight, because Dwight's logged in and he's a rep, so hopefully we'll see an error. There we go, failed to add deal. So the RLS is working. Okay, I'm going to quickly sign in as Pam. She's an admin. There we go. And Pam should be able to add a deal for somebody else, i.e. Dwight. There we go. Brilliant. So before you move on to the next scrim, check one last time that there are no rows in your sales deals table that have anything in the name column. They should all just have data in user ID and value. When we fix our chart so that it looks nice, why don't you make sure that you have deals for at least, say,